Yes, and share the audio and share the audio. Here's open.
No, I think share audio is, I mean,
No, I think it's correct. The setting is okay.
share audio means share to the Zoom.
Yeah, it is. It's open. It's open. So it's taking from this microphone.
Oh,
Yeah.
okay.
So it's already taken from the microphone.
I thought you need to share here. If you click, share computer sound. Yeah, because it's play from computer. Stereo. Yeah, thanks. Yeah,
I don't know if that is.
We can play Google Sound.
So.
Okay, let's go to the next session. My name is Jian Wang. I'm a co-PI at the iHub Institute. As you know, probably now the whole conference is centered on the 5 HDR Institute. And today, this session, we have introduction from 2 of them. The first one from Dr. Shijie Xu, and from University of Washington. He's the PI of the I3D3 Institute. We also have another one as a speaker. Okay, cool. I'll try to find your name. And Alif Ardakin from UC as a co-PI or co-director for the ID4 Institute. Go ahead.
All right. Good morning, everyone. My name is Shijie Xu. I'm the director of the HDR Institute. I'm a physics professor at University of Washington. Okay, here is it better? Good. I'm a professor in physics at University of Washington and also adjunct faculty at ECE in University of Washington. It's always great to hear the starting of the meeting with Tanya's energetic welcoming. Thank you, Tanya. We also have some exercise with the fire drill this morning. So I believe everyone has wake up even without too much coffee. In HDR3, we cover the science in space across the 30 order magnitude emitters, from the smallest, the inner core of the nuclear composition. Oh, there's an echo. Okay, all right. And the largest to the universe, the study how black hole evolve, binary massive compact objects dance around each other. Also, we study neuroscience in the cell level. So what are common challenges across these different domains? We are all require ultra low latency, for example, even down to the microsecond level of the inference time, and also high throughput. And the throughput is even 1 order of magnitude greater than Google annual data volume process. Altogether, with the 3 different domains, scientists and engineers try to solve these common challenges. And here comes to the HDR3. Stand for Accelerated AI Algorithms for Data-Driven Discovery. And I will comment on how we accelerate the algorithm using a coprocessor with a cutting-edge technology. Among the 3 domains, we are composed of science and engineers from 3 different areas. The scientific applications defined by the scientists, and we require the new novel AI algorithms together with computer scientists to solve the problems we need. But it's not enough because we require ultra low latency and high throughput. Therefore, we have to collaborate with electrical engineers who know how to accelerate hardware for the computing requirements. Our mission is to advance scientific discovery through real-time AI applications at scale. And our vision is to empower researchers able to gain the knowledge we develop and apply to their field friendly. We start from 2021 and with a $15 million, and we got additional 1.2 million for supplement grant to run the events like this, and we host two HDR ecosystem in the past years. This is the 5th edition. We just get approval of the no-cost extension to September 30th, 2027. We are composed of 21 institutions with 170 members. 75% of them are trainees, means graduate students, postdocs, and we have a few undergrad and postbac. We across the geographical domain in US. We also engage international affiliate members from Taiwan and also in Europe. As I commented, we have 3 domain areas: high-energy physics, multi-messenger astrophysics, neuroscience, and together with the computer science and electrical engineers. And among these domains, high-energy physics is a little bit more people, but in general, within the Poisson statistical uncertainty, we are counted as equally distributed among the different domains. We have 35 faculty and staff so far. We have outstanding members, and during these years of the awards, we got nominated to the national recognitions as Professor Kat Schober as a National Academician, and Professor Damien Chen from UIUC, who have nominated multiple IEEE and AAAI fellow. And we have multiple early career awards, and they propose the domains and also their research along the line of the HCDC and collaborate with us. We have a couple of HCDC alumni. They are advanced to the tenure track position in academic, and we have outstanding graduate students who also awarded the Google Fellow. The flagship program we have is a postbac. Through the years, we have award for cohorts, and this year is our final year for NCE, and we can support 2 cohorts. But we have 1 more from NSF areas program. This is a program support a local student from UIC here to do the regular academic undergrad research, and also can have 1 postbac collaborate with one of our HCDC member institutions. And this year, we have 1 UIC areas postbac member from underrepresented cohort and visit Duke for 1 year for neutrino research. I would like to show statistics. The number of applications for our programs grows through the years. And this is the effort that we regularly attend the nationwide underrepresented organization programs to promote events. We have made tremendous successful productivities, including both the scientific applications and also the software open source, open for the scientific communities. And right now, you could see that we have achieved more than 13,000 citations, and the number of citations grow exponentially. This shows our impact really multiplied. For the flagship software we have, I'll comment more, but it is HRS for MLO, and we have received more than 2,100 stars in the GitHub. The new software, Supersonic, we just put online. This is at the scientific experiment download level. So currently, over the nationwide, we have 11 experiments, and start downloading and try this out. So what makes AI for science unique in A3D3? When we talk about AI, there are 2 major steps. First, you train the data by understanding the feature of the data and thinking about all the trustworthy, ethic, and also all the criteria we want, how AI treat our data. Then we train it and get the best weight and to appropriate to be used for the science. These consume a lot of computing resource. But this is just a step one, because once you get the trained data, you want to apply that to the application usage, and it's an inference. This is what HC3 focus on. We focus on the inference, how we can run it more efficiently and more power effective. It means we are able to run AI effectively on the edge. The reason why we can do that is because we try to bring everyone together to solve central problems. Then we can deploy the cross-disciplinary collaborations. So, all right. One major thing we do is that we try to leverage the hardware algorithm code design for the edge AI. When you talk about algorithm, we are tackling scientific data challenge. And the recent data is being moving to a direction that the data is more irregular distributed and is scarce or limited labels. And we want interpretability and transparency for AI models. For the hardware, it requires platform which can optimize for the support these kind of novel AI algorithms, and it can address the need for low latency, high throughput, and we want to think about the consideration of the power and memory constraints on the hardware. We developed a flagship software called HDR for MLO. It allows users to easily deploy the preference AI models trained in PyTorch, in Python, to the high-level synthesis language. Then we can compile that using the consortium software, then can deploy to FPGA. Through this process, you can also do the digital verification, can help accelerate the ASIC design. One example of successful applications, we have deployed the anomaly detection algorithm trained in AI to the Large Hadron Collider high-energy physics applications. And through this HDR formula, in the past few years, we have successfully convinced both largest experiment Atlas and CMS to use this anomaly detection algorithm on the level 1 trigger to reduce the data volume. And therefore, you can really target on the interesting data for science. And this is one example of the publication. And the orange distribution will not be there. We will not take those data without using the anomaly detection algorithm. Otherwise, it will just be following this blue line. But once you have the AI can run on the edge device, how can we scale it? So we adopt the concept of the client-server applications, aka inference as a service. And we develop a software. It's called Service for Optimized Network Interface on Co-processors. This software package can apply to not just a GPU, but can also apply to FPGA. So we advanced that to be a supersonic. The major difference from Sonic is we add a lot more monitoring tools. Then this is really allow you to optimize your resource usage and also in the distributed clusters. And this has been adapted to multiple high-energy physics and also the neutrino and even the gravitational wave experiment. So I would like to share with you that one of the demos we contribute to the Genesis mission.
Our goal is to use the American Science Cloud to accelerate discovery across experiments from Dune to LHC through a shared inference as a service platform. This enables rapid processing of massive data, which is critical for detecting time-sensitive signatures like supernova explosions with Dune. For Atlas, inference as a service allows deploying larger, more capable AI models in production. We demonstrate 4 different scientific workflows from Atlas, Dune, and Microboon in this demo. We start with this web-based portal. Through this interface, users submit inference as a service requests in the intelligent Triton server controller. The portal provides a set of predefined production-level scientific workflows for different experiments. Here, the user selects the experiment and workflow, specifies the dataset name, chooses the number of events to process, and requests the computing resources needed for the job. In the future, those resource requirements can be determined automatically by the server. Once the form is complete, the top panel summarizes the request. The user clicks submit and waits for the server to respond. The server then launches Triton instances for that request and returns a URL to the user. At that point, the user can use the URL to submit the client jobs through either the worldwide LHC computing grid or the Fermi Grid computing platform. While those client jobs are running, we can monitor the system through Grafana dashboards. First, we look at the Triton server model matrix dashboard, which focuses on model performance. Two charts are especially useful here. The inference request rate shows how quickly requests are arriving at the server. The model inference rate shows how quickly the server is processing those requests. This allows us to inspect performance across all machine learning models currently hosted by the server. The second dashboard is the Triton Inference Server dashboard. This provides an overall view of server status, including backend activity, model queue time, cumulative successful inference requests, and the scale-up metric. The scale-up metric helps the intelligent Triton server controller determine when additional computing resources are needed. Here, the backend activity shows that as requests build up in the queue, the controller responds by launching more computing resources, which reduce queue pressure. This is a core capability introduced during American Science Cloud, delivering on-demand computing to high-energy physics and nuclear physics experiments. Finally, the Envoy monitoring gRPC dashboard shows the overall status of the inference service from load balancer perspective. It tracks upstream and downstream requests, request status, and overall traffic patterns. This is the first end-to-end multi-experiment, multi-facility demonstration of inferences service.
Right. So let me share with you how the platform I just mentioned, and that can be applied to the science. And for example, we can apply to the real-time gravitational wave alerts. When you have a binary compact object, they merge, they will disturb space and time, and we can study and measure such ripple of the space-time in a very sensitive device called the LIGO. And our goal is to measure the data and from the physical system, but also we can do the inference to estimate what the physical system parameter is. With the inference service and also the edge inference at scale, we are able to apply to the upcoming next generation of the observatory to study the most dramatic cosmic event in the universe. And here allow us to deploy more advanced AI model to such a system. In the neuroscience, we can think about autonomous lab for the real-time closed-loop BCI, brain-computer interface. And we have a nano neural pixel probe, which can probe the animal's brain. And what we could do is to, once we take the data, we can run the FPGA to detect the signal in a microsecond level, for example, the anomaly at the threshold. Then we can apply to the modulation system, and we can do a closed loop operation to learn more how the brain and behavior relation is for the animals. Through the SVT3 platform and also the HDR ecosystem, we try to grow face ML community. Face community is going more than just the 3 domains I just mentioned. For example, the plasma, the quantum physics, and also the accelerator beam control physics. So as long as you are looking for low latency, high throughput, real-time control modules, or the customized process elements could all collaborate with SVT3. And we also collaborate with the prime industry, for example, Google, AMD, Xilinx, Intel, Microsoft, and we all try to achieve the goal to have AI-ready data more efficient. We run the workshop in the schools. And for example, just the end of this month in San Diego, we have the next version of FaceML conference. And we are trying to have a user-friendly ecosystem environment for experts to discuss the application of the FaceML technology. And I will talk about briefly what's the future of ACD3. So thinking about the directions, agentic AI has been a buzzword and super hot in the past years. We are also working on the first deployment of the agentic AI to the high-energy physics. And this is a paper just really fresh spring this year. And we could think about how to bring data from the sensor all the way to publication using agentic flow. Then we have a broader community-driven effort, and we have white papers going on. And for example, Mark has been a really wonderful the ambassador for ACD3 for the broad community in higher physics, involving the white paper for at hardware level and also at the global multiple particle physics level. And here is an opportunity for us to make the autonomous lab application to the higher physics. We start a FaceML Foundation. And if you look at the current leadership, the president, Phil Harris, is the deputy director of ACD3. And Tia and Javier, they are the associate PI for our ACD3 Institute. And Alex and Niang, they are the advisor for ACD3. So literally, the leaders of the foundation are driven by the ACD3 leadership. Through FaceML, ACD3 member institution can be part of this academium and also can be part of these open source tools and support. People can be going through the support we funded from these foundations. Then this allows us to also work more closely with the industry to support the science. And we actively contribute to the Genesis mission. It's started by DOE, but my understanding is that NSF also just make an announcement to have a close collaboration with the Genesis mission for the future run. So we want to take these opportunities. And for example, in ACD3 high-energy physics sub-area, and 80% of PI have got one or more than one funding. It's a small funding. You could operate for 9 months to test your idea, but you can use that as a seed to submit a relatively bigger funding for the phase 2 round. But the total funding of the Genesis mission, based on the reference, is 5 billion. We also try to grow the ecosystem with industry, and this is one of the lead by Mark and post HDR formula. And this is an opportunity for engaging industry to know more about our tool and then can apply to their product and make it a commercial usage. And we also try to cooperate more with the industry. For example, this is an attempt with Amazon and NVIDIA support in Washington to collaborate with the University of Tsukuba as a cross-Pacific collaborations. We apply this closed-loop idea to the sleep apnea research and also the control. In summary, ACD3 try to enable real-time discovery to a wide application of science and engineers, and we are driving the scalable AI ecosystems through the FaceML Foundation, through the HDR ecosystem, and also with a broader the community in high physics and gravitational physics. We would like to build a multi-scale phenomenon, and we are looking forward to have more close relationship with all the HDR members. And so if you think about you want to get AI-ready data, and you want to put this pipeline earlier, you would like to just get the data from the sensor, but it's already prepared, ready for your usage. And this is a part that ACD3 can collaborate with you. Thank you very much. Yeah.
Very impressive, thank you. I didn't notice that you had engaged the atmospheric science community as much, and I thought there was rich ground there for your technology. Have you been working in that area?
Sorry, you talk about astrophysics? Sorry, which area?
Atmospheric sciences, meteorology, weather forecast, climate.
Oh, no, we haven't. So if you could introduce us, we can brainstorm more ideas. This is definitely a brand new area for us.
Has all the elements that your technology seems to enhance.
Great, that's great. Yeah.
Similarly. And to follow up, I mean, with the atmospheric sciences, we have iGuide Institute hosting it, right? So this is exactly the conversations we had, and I hope so. In ecology and biodiversity, field biology more generally, and field environmental sciences, the conversations are very quickly moving to having to edge computing conversation. Right, and so we looked last year at the software, and which is great, but it's not field deployable. So we would love to talk about how to move edge computing this version to instances where they're field deployable, resource constrained, not just compute constraint.
Yeah.
So we can take embodied AI out into the field.
Yeah, that's great. So we also noticed that the technology improvement, the coprocessor can be more effective, and it's being continuously pushed by the industry. The technology we have for FPGA was a time when the coprocessor is too expensive to run in terms of the resource consumption. But given the opportunity that more coprocessor being able to bring closer to the edge, then the way we do the quantization, the pruning of the AI model can be applicable for those coprocessor. I think that will be a great place we can continue the conversations for your application.
Okay, let's move on and have next speaker for the ID4 Institute.
Hi, thank you.
Okay. Hi, everybody. So I'm Elif Artekin. I'm actually the co-director of ID4, the Institute for Data-Driven Dynamical Design. And the reason I'm here is that our director, Eric Tober from Colorado School of Mines, in large part as a result of some of the things he'd been involved in, it's actually split now. He's Rail's startup company, Periodic Labs, which is a good thing for periodic labs, and for me, a loss to lose my favorite experimental collaborator. But I am hoping to kind of walk you into our problem space today, the types of things that we work on, and then explain our philosophy and approach, and maybe show you a little bit of the perspective that we have. We're an interesting HDR. I think our team includes computational materials and computational physics people like myself, material science, experimentalists as well. But we also have larger scales, so metamaterials, and even architects. We have architects on our team. And so the way that these domains come together and the way that they link, I hope to show you a little bit about today. In addition to that, we have a large number of computer scientists, data scientists as well. And I'll show you some of the different things that we've been able to do bringing this group of people together. So these are some of the institutions, some of the faculty who have been involved in our work. Okay, so let me walk you into a part of our problem space. This is the part that I think a lot about. So on this map, what you are actually looking at here is a two-dimensional projection of the space of all currently cataloged or known crystalline inorganic materials, right? Approximately 200,000, a little bit less than that. Most of them you don't see because they're white dots on white background, but some of them you see, black dots. And the way that this map is made, right, dots that are closer together are materials that share a similar structure or chemistry, and those that are further apart are more different from each other. We have something like 200,000 known materials, but the space of possible materials you might search if you want to find new superconductors, if you want to find new thermoelectric materials, it's essentially infinite, right? The way that we can collect atoms and electrons together in a way that give rise to properties is an infinite search space. So that, to me, motivates a really interesting question, which is, first of all, why do we only have less than 200,000? Is that all nature allows? Are there more out there? And how can we search for them? How can we find them in more efficient or practical ways, right? And then kind of near and dear to my own heart, we have our guiding principles, right? We're in a space that I would argue, compared to many of the domain areas where we've seen AI and ML methods developed, we are in a space where I think we are a little bit data poor compared to many others. Like I said, 200,000 known materials, 0 known room temperature superconductors. Do they exist? Who knows, right? But we do have guiding principles. We have physics. We have things like the F equals ma of the world of nuclei and electrons, right? The Schrödinger equation. That's a very powerful tool that we can bring to bear on this problem, right? And so if you think about some of these quantum mechanical governing principles that we have, they let us do things like, make these links between the structure of a material and that material's properties. So there we go. So in ID4, our big goal is in the material space and also at larger scales, imagining ways to accelerate the design of new materials, new molecules, new structures, specifically new mechanisms that underlie the performance of those materials or structures or systems. And our team has really been trying to address this design challenge through this targeted strategy search simulation, bringing together human expertise and experiment. We do this by bringing this group of people together, right? Theorists, experimentalists, data scientists, computer scientists, that otherwise I don't think would have had the dedicated time that we had to sit together in rooms where computer scientists could learn about my problem and I could learn about their problem, their approaches, and we could think about what could we do, what can we do together that is otherwise different. So here, for example, again, those quantum mechanical equations that I told you about, those are, if you think about it, they're kind of formulated as a forward problem, right? Give me a structure, I will tell you about its properties. I will tell you what that material does. I can try to simulate that material. But in reality, what we really want to do is go the other way. You have a target property you are interested in, and we want to find the material that best hosts that particular property. And the search space is gigantic, and our known number of examples are sparse and very few within that search space. So how do we design new ML methods or approaches that out of the box are designed for that parameter, for that structure of a problem? Different, I would argue, than a lot of the domain areas where AI and ML methods were originally developed, right? Data-rich, learnable targets. We have an interesting, different structure to the kind of problem that we're working on here. And that's kind of what I want to highlight here with this slide. So I think the opportunity we have is creating new AI or ML approaches that are inspired by the domain of materials, of structures, things designed for regimes that are a little bit different. And so these are ways that I think this regime is different. We have in materials quite a bit of data scarcity, right? We want in material, sometimes I think I'm in the minority when I say this nowadays, but we want models that are interpretable and understandable and connect back to physical causality and mechanisms and understanding. And then in materials, I'm going to kind of make a bit of a bigger point about this today, symmetry, right? We have physical constraints. We have what my computer science colleagues call inductive biases, and I call physics, rules of symmetry that tell us how materials should work and why they work the way that they work. So our thinking and our goal has really been to come up with new approaches that are designed for that structure of a problem to work on, right? How do we bring physics-informed search, tools like automatic differentiation, generative models, active learning into our search strategies? How do we embed uncertainties into our simulation processes? How do we target experiments strategically? And so we're a team that, across the board in all these different domain areas I'll show on the next slide, we've developed a pretty large suite of software and tools to use for the community. And like I said, it's very interesting to me that a lot of this work is scale spanning, right? So I myself, I motivated this from the materials side. I'm a materials person, but we have others who are working on metamaterials, a little bit larger scale. We have architects, right, who are also designing structures as well. So, okay, so some things to think about here. For example, application areas, metal organic frameworks, so things you might be interested in for gas capture and storage. Energy materials, batteries, fuel cells, things that transport ions or atoms and are durable, don't degrade so quickly. Soft robotic systems or green architectures and photocatalytic systems, so things you might be interested in for more green chemistry or things like this. I'm going to tell you this story today, and it's going to be motivated. It's going to start from the materials discovery side, but I'm going to link it to larger scales at the end as well. So we already talked a lot about this. The space of possible materials is huge, essentially infinite, but most of that infinite space is junk. It's not useful, right? There are ways of assembling atoms that don't that nature doesn't allow, that are not thermodynamically feasible or otherwise don't want to form. There are, and so again, you can kind of see here, we have a large search space and not a lot of known examples. And the materials we're using in modern technologies today, they are complex, more complex than before. So our modern steels, for example, can go up to something like up to 20 elements, something like this, right? Our battery cathode materials, maybe 5 elements or so. So the complexity of these materials itself is actually growing as well. So here's the quick story I'm going to tell you, and the story here is kind of interesting because this was, for example, my first machine learning conference paper. It was, and I'm new in that world, but I got to work with computer scientists to think about how can we apply generative AI to material search problems. This was kind of our first work, and it was really like part of this convergent effort to come up with approaches that were designed for data sparse regimes and designed in ways that respect what we know about physics, our inductive biases, right? So generative AI, I think we all know this, right? What is this? What is a generative model? Mathematically, I think the cleanest way to think about this is it's a learned probability distribution over objects that you want to generate. You take your known examples, you try implicitly or explicitly, imagine they're drawn from some probability density. And once you've learned or understood that probability density, you sample it. And this is how our language models work. This is how image generation works. Our question was, can we do this for crystals? Can we do this for inorganic crystalline materials? And so in this case, there's some interesting things here, right? So we can take our data sets of known crystals. I already said they're small. And we can try to train and learn a model. We can try to train a model, learn the patterns in the underlying distribution of known crystals, and then sample from it, right? Generate new examples that are plausibly candidate new materials. You might even condition your generation on some target, crystals coming from a certain symmetry group or crystals that have a certain composition or something like this. So here's where the physics comes in. That search space is really large, but crystals are constrained, right? They have certain symmetries associated with them. They're periodic and they tile 3D space in regular ways. I think that symmetry is pretty critical to getting a good generative model for crystals. So if I were to just make a box and throw atoms in it, the chances that I'm going to land on a high symmetry structure that nature gives us is basically 0, right? The space of symmetric structures is of measure 0 in the space of all possible ways of arranging atoms in space. And so those symmetries we kind of want to respect during the generation process. Symmetries related to, by symmetries, what I really mean is invariance under certain transformations. If I take a cubic lattice square and I send everybody here out of the room and I rotate it by 90 degrees and then I bring you back in and I say, did I do anything? You would have no way of answering that question. You wouldn't know, right? That symmetry operation leaves the crystal invariant or unchanged. Okay, so we want to embed that into our generation process. So if you have worked with image generation or diffusion models, you've probably seen this image like 1,000 times by now. Denoising diffusion models, this idea of image generation as this process in which we have taken all the images we have on the internet, in a prescribed or known way, add noise to that, right? Gaussian noise going sort of left to right here until we have something that looks like isotropic Gaussian noise at the end. And what our diffusion model does is it learns to go the other way. It learns to denoise that noisy isotropic blob of Gaussian pixel values here on the right-hand side. interesting how that works, right? Interesting that we can do it. This is kind of the magic of some of these diffusion models themselves. But if you learn to denoise from the set of known images, then you can just start from pure Gaussian noise and apply that denoising process and come up with new examples. So that's how image generation works. Here's what we did, right? We applied this to the space of crystals. I take atoms distributed in space in a known way from our space of known crystals. I wiggle them around until I get something noisy. And then we try to learn the process of wiggling them back or denoising them. Here's the algorithm that we came up with. Denoising, but not just random rejiggling around of the atoms, moving them around in a way that respects their crystallographic symmetry. So this is group theoretic machine learning here. This is doing denoising in a way that embeds those physical symmetries. This is, I think, our sweet sauce. This is the way that we're able to make up for the fact that we don't have a lot of data in our space. And so I'll show you what that denoising process looks like. This is kind of the fun that we get to do because we have computer scientists and materials physicists working together, right? So this is denoising, generating a crystal. You'll notice some atoms are not moving at all. By symmetry, they're restricted to a zero-dimensional space. Some are moving in 1D. By symmetry, they're restricted to a one-dimensional space. We're symmetry preserving, denoising our crystal here. And you kind of see that at the end, we land on something that looks like a plausible crystal. So, oops, that's not what I wanted to do. Okay, so we make crystals from this, and I don't, one thing I've learned is that in materials, sort of machine learning world, your papers have to have these tables of bold numbers. So here's ours. And I'm not gonna make a big deal out of this. I just wanna point one thing out, which is that, so our model is this thing, space group equivariant diffusion, the one on the bottom, the rows on the bottom. The ones on top are Microsoft, Google, right? Tech giants. And for now, for a fleeting moment in time, our physics embedded model is winning, right? We have a model that is generating plausible crystals according to certain metrics, and in a way that is outperforming what has come to us from the tech industry. Now that, I think has a lot to do with this convergence we put together, this team that kind of is computer scientists, mathematicians, physicists, crystallographers working together to design new approaches that really are dedicated to, meant for the materials domain. I don't think we're gonna win forever. Those guys have generated and much larger data sets than we have. They are able to scale and perform, but for this moment in time, it gives me probably more joy than it should that a purely academic group has been able, and a very dedicated graduate student who sat in his chair many nights until 2 a.m. until this thing worked, and it was iteration 12, for us to be able to put this model together. And I think that says a lot about the role of academia in this new world that we have, right? And so where is this going? Well, a lot of the tech industry is now using and adapting some of these methods in their own generative models. We have our own team members applying it to 2D topological materials, to chemically guided search for new materials, to metal organic frameworks. It's quite exciting because we've embedded the physics. Now pick any property of a material that you want that relies on symmetry, breaking. And we have ways to do targeted generation accounting for those symmetries themselves. So let me quickly then show you how this connects to the larger scales, right? So we have people working in our team on metamaterials, larger scale design, using the same tools, right? Symmetry-based tools, and adapting tools that use automatic differentiation. For example, we're able to target and we're able to use the same symmetry reasoning and symmetry-aware neural networks to be able to do things like design metamaterials here. The idea is to try to, you push on the material and you want to focus the energy, the vibrations to that target region there. And so this is a neural network designing the structure of that tool in order to be able to do that. Designed by a neural network, and here's the comparison of the experiment and the simulation, right? You can kind of see the experiment is the actually designed metamaterial itself. So this is also using those tools that account for symmetry as well. And now, and then just kind of scaling up here, even one more degree. I told you we had architects on our team. We do. We have architects who design structures. And in particular, in this picture, you see Sigrid Adriansens from Princeton, Ryan Adams as well, who's on our team. Sigrid is an architect, and what she does is she works on kirigami structures. So the idea is in order to be able to ship and transport things that are going to become structural components, can you start with something like a sheet of steel or metal? Can you cut holes in that system, and then you poke it and it kind of pops up? And it pops up in a way that gives you something that is mechanically strong and stable. So you can ship it in 2 dimensions, poke and deploy it into 3 dimensions when it gets where it wants to go, and then use it as an actual structural component inside of a material. And so here again, we were able to use the same symmetry preserving tools to come up with these layered structures like the one that you're seeing here. I think I can point here. So on the lower left, some of her structures actually were exhibited in Venice at an art display. You can literally stand on this thing and it will withhold your weight, even though it's basically a cut 2D material that's been popped out. And it was designed by the same symmetry preserving neural network tools that we developed and applied in the material space itself, right? And so this is again kind of looking at that structure one more time. And so you can kind of see, I think from the image on the right, how the pop out takes place within the tool itself. So hopefully that gives you a little bit of an idea for the way we think about our problems and ways in which, bringing together, I think, if I think back historically, 2010s, in my field, we had a bit of a convergence. It was theorists, computational people, and experimentalists who worked together. I think separately from that, we had, in the computer science space, we had data science and computer science come together. And I think what we've been able to do as part of HDR and part of this ecosystem is bring all of those groups together now to try to do things that otherwise may not have happened or take place. And so this is what I find really exciting and fun and kind of our opportunity in our world. So I'll just end with a couple of different things, just in terms of broader impacts from last year. ID4 runs a lot of workshops. We ran 5, I'm sorry, I updated this. I think I sent you the wrong version of my slides. I'm sorry. So in the last year, we held 6 different workshops. We have 3 workshops planned for this coming year on a variety of topics. So one of them is uniting machine and human intelligence. Another one is going to be focused on some of the structural or AI for structures and engineering. And then finally, one on putting together computational quantum chemistry tools with machine learning for accelerating our simulation, improving the accuracy and accelerating our simulation capabilities as well. Oh, here it is. Wait. Okay. There we are. Okay. So these were our workshops from the last year. We worked our program grew up with a large number of assistant faculty professors who have actually now been promoted. And so it's been really nice to be able to see the growth and the development. And I think we do a lot of work trying to mentor our junior faculty. That's been an important theme for us as well. And here's some of our workshops that are planned for this coming year as well. We're also going into no-cost extension. Collaboration opportunities. We're generally, we love to work with everybody. I know it's an NCE year, but to the extent that there are ways we can do things together, we're excited to be able to do that as well. So I'll stop there. Thank you very much.
Just a quick question. What was the name of the architect for there?
So the architect, her name is Sigrid Adriansens at Princeton.
Thank you very much for that talk. Towards the beginning, you talked a lot about how the effective convergence on your group made a really big difference. You get a sense that a lot of your junior folks, the students who've gone through that experience, you get the sense they might have, integrated that into their way of thinking about work going forward?
I do. I really do. I see it in the way they think about problems. I see it in the types of questions they ask. And it's interesting because for the students who started in this program, that is what they know. That is how they have learned to do research. And they now see it that they don't know anything different, which is very interesting. That they are my computational material science students expect to have a computer science collaborator. They expect to have an experimental collaborator. I feel like an old person when I tell them, it wasn't always this way.
Let's add to the session and thank the speaker again.
Thank you so much for both those talks. That was wonderful. Currently, I guess we have a break till 10:30, and we need to take off the posters before I guess during this break, so we can release the poster boards. We'll come back here 10:30 for the paper and discussion session.
Thank you. And as we go into break, I just want to make a call out for, I know that especially breakfast this morning had really few options for a lot of the people who would be vegan or vegetarian or have other dietary preferences. More things have been brought over right now. So please, if you, especially this morning, if you felt like you didn't have the options that you really wanted, please make sure you take advantage of the stuff that we have brought over now, and we'll have more going forward at the other meals. Thank you.
And if you are a position paper presenter in the next session, come and meet. Yeah.
Oh, do you want to double check this?
Okay, so this it's the session. This was the afternoon. This was the morning session. So slides. Yeah. Yes, it's not. So you need to download it.
Yeah, the first one.
Okay, it's big. Is it big or
Somehow, yeah, just have some features.
okay?
So I would invite you to upload your slide. Oh, yeah.
Yeah, all the slides are here.
Okay,
Here, that's here, right?
yeah.
Okay, so that's okay. So anyone else needs their slide downloaded or like maybe? Okay. Others, are you guys okay to directly presenting through Google Slides, or do you want to be downloaded? If you have like big like figures or videos, we need to download it. I got her download.
I think all of them could be just download. Yeah.
Download it.
No innovations. Yeah. Should be easy. Just download.
Okay. Let me see.
Oh, I see your point.
I can just directly play
You
from.
can directly play.
Yeah. So if you guys directly play through this, that would become easier.
Exactly. It's easy. So, yeah.
UI have yours downloaded. So UI is going first, so that's okay. So 1, 2.
Rami is here, and then we have
2, 3.
Smith is here,
Yeah.
and we have one more.
One more.
Will
This one is. This one I probably download because it seems like
yeah,
a
it's PDF, right? Download is
download PDF.
Download is better.
Download is
And we have one more.
yeah, we have one. Okay, close. Okay. Okay, discussion session.
So some more.
This one slides. Peter Darch. Yes, we have.
Do you know Peter is here or?
Yes, Peter is. I saw him. Yeah, that is the last year.
Peter?
No, here. That's in that near Eric. So Peter, so I would and I get yes.
Peter and Rami. They are
Yeah, they have in the same breakout. Yes.
So maybe Peter should go. And sometime we'll go the.
That's fine. We can change it also.
Yeah. Okay. Good. All right.
That's fine. So I think Smith's presentation. That's yes, right? Open file. Okay, it still opens it here. I don't know why. Downloaded it.
Right. Maybe I can talk about the plan.
Yeah.
Anna, could you
Yeah.
go through the notes?
Yeah,
folder?
give me 1 second. Okay, so this is Smita, right? Okay.
Yeah.
Oh, but it still opens in the maybe
think
it
it's-
doesn't. It's okay.
Now worry about this.
Yeah,
It's all right. Did you go through the notes folder?
the notes folder. Yes. Yeah, Peter is here as well.
Notes? Yeah.
Yeah, Peter is here as well.
I'm Shi Jian. I'll be the chair for the next session.
So yeah,
And
notes.
the note folder, there's a Google Doc. Could you open it?
Yeah. So
And
this is
there are four tabs
okay.
for each
Yeah.
group.
So yeah, you guys can take
Right.
notes there.
So what I did is that I already copied each of your questions.
Yeah.
They are wonderful questions, yeah. And I believe your plan is to discuss those questions in each of your breakout sessions. But before you start the sessions, you want to appoint one scribe
Right.
and write notes to this one. And could you open it?
Yes, sorry.
And put the scribe's name there. And you cannot be the scribe, you have to moderate it.
Yeah.
Someone else.
Yeah.
To do it, yeah, or everyone do it together, either way is fine. But then, invite everyone, put their names, participants there. Yeah, similar to what you did, their name, their institute, definitely.
Quick question, so, is there a link that we can send to everyone?
It is,
The QR code.
you can add the QR code, but
The
also in
link-
the mail I sent you guys, that has links to this notes directory. The one I sent you, like
This
the one this morning, yeah, no, I sent you like maybe last week also. So that has the slides, wherever you put the slides, that same email has the links to the notes.
And one thing to be done is that I invite each of you in the LinkedIn. If you can accept me, I can find your email. Then I can send the QR code in the link to you directly.
Yeah.
I think, hold on, in each breakout room, we can use the projector.
If you want, you don't need to, but if you want, you can use. This room might not have like, this two are same
Yeah.
projectors, so there's only one
I see.
for two groups, but
But the good thing is that all of them share the same QR code, just one
Yeah.
document.
yeah, it's one
So
document.
if people have one QR code, people can scan it, they can type.
Yeah,
Right.
we can do
So
that.
I can send to you, before the end of conference, right? So you can go to send my thing or. So a point one slide, invite everyone to their name or just spend their name, so you can put in their name. Right, then, the squad can take notes. But finally, we will bring everyone back here and each team, 5 minutes of presentation. Right. So I think it might be easier, you just show your Google Doc and just come on verbal. And I naturally will be the speaker. And so I think Rami and Peter will sound that, yeah. But if you want to delegate to someone else, it's also fine.
So, yeah.
Okay.
And-
Catherine?
Yeah. And when you are here, just hide this thing when you're presenting, just click on the more and hide this.
Yeah.
Hide this.
Okay, I
so
see your
that-
point.
Yeah, so it would like,
Maybe-
whenever we did like, no, the first one I can hide, but then like whenever you hit escape, it will show up again.
Yeah.
So
Okay.
just hide it.
Okay, will do.
And for you, I think since you have a PDF, you have to use this escape kind of, so that enters the full mode. You will probably have to. So whenever like, if it is there on the screen, just hide it so that like, otherwise it just blocks the screen.
Okay.
So your presentation is downloaded and it's in
Maybe you can help out later.
yeah, I can help
Yeah.
out later also if you have problems, but
Okay, good.
yeah.
I have another quick question. How long is the breakout?
Breakout will be like 45 minutes, but like depends on like if you guys stick to 5 minutes. So that also depends on you guys. So if each of you has 5 minutes, then we'll have 45 minutes for breakout.
So we come back at 11.
Just like at around 11:40 or something like that. Yeah.
So yeah, in each of your talk,
Yeah.
try to talk about the idea, then invite everyone, what kind of question you want to discuss. It's only 5 minutes. But you keep it later, you have 10 minutes.
Yeah. But yeah, like, and I'll give you like 5 minutes before the end of your session. I'll just come and not disturb you, and I'll just show 5 minutes left, and then like so you will know you have 5 minutes to wrap up. Okay. Right. Okay. Thank you so much.
Okay. Yeah, I'll send you the link of the document. Yeah. I also.
All right. Yeah.
And then this is the. You receive so many, we can go through them. Yeah. We start.
Yes, yes, we do. Yeah, so said that these two then we can talk. Your space, yeah, so I'll finish that. So basically. Sorry. Yeah.
That's what I was so like just this one's on that floor. Yes. That's it. All our I think I got like my way or I face on I accept that responsibility. So I know. They're traveling. Yeah. I know. I don't know. Yeah, I did. Then I. Well, being on the slide. Sure. And I'll figure out.
Hi, everyone. I'm not quite sure where my counterpart went, but I know we've got a session that should start. Okay, if you are part of this next session, please come on. I was looking for you. I'll go get people from the hallway.
Hello. Hopefully everyone have a fruitful discussion in the coffee break. And when you have opportunity, could you scan this QR code? Because during the breakout session, we will use this notebook to document the discussions. All right. Without further ado, we should start. In the session of the responsible and trustworthy AI enable science requiring practice, we will bring from the privacy preserving and uncertainty aware methods to ethical governance and human oversight to reproducible AI workflows. And today we have these 4 areas, and each area we try to motivate with the in time and questions, also with the challenging problems that we have 4 groups that want to discuss in the next 45 minutes. But before that, we will invite each of the lead of the session have 5 minutes time to briefly talk about the questions and motivations we'd like to discuss in each of the sessions. So this is the plan. We have a Google Doc, and if you go through Xiaowen and also Anand's email, you could find the link to all the Google Drive with the documents. And once you click this Google Doc or scan this QR code, you can access the Google document. And we have 4 tabs. And your lead in each session will help you to guide through, write down the document. And after the 45 minutes breakout, we'll invite everyone back here to do the final closing. All right. So we will go through each of the session in this order. And first, we would like to invite our Professor Yuan Lin to talk about the session A. Okay.
Switch to PowerPoints.
You need to reload.
Can I switch to PowerPoint?
You want the PowerPoint?
Oh yeah, never mind.
Yeah.
I can do this. Okay. Okay. Hello everyone. My name is Yulin, and I'm here to talk about the privacy preserving dimensions of AI technologies. And so I am an assistant professor in Department of Geography and GIS. So I'm in the geography department. So today my topic about privacy is mostly focused on location privacy. There has been a long discussion about location privacy in the geospatial literature and tech industries. In probably 20 years ago, there has been a lot of literature talking about cartographic surveillance and controls, by the emerging GPS technologies and satellite imageries. And there are also concepts like geoslavery and geoprivacy emerging at that time. So in the light of that line of literature, there has been a lot of emerging geospatial methods developed to protect location privacy. So basically, these methods are used to kind of transform the explicit location information, such as addresses or geospatial coordinates, so that they cannot be used to review individual identities. So here is just like a short list of the selected methods. So you can see that there has been a lot of literature in this area in geography developed to protect location privacy. So with the machine learning methods emerging about 5 years ago, so there has been a new kind of location privacy risk emerging. There has been research documenting how machine learning models can be used to infer user profiles from location data that has been geomasked. So even after we apply those geospatial masking methods to location data that we've developed in the past, today's machine learning models can still make use of those masked location data to infer sensitive user profiles. And in a separate study, I've also talked about kind of discuss this kind of risk in terms of how algorithmic profiling and inference has been a new risk in the machine learning and AI era. So with the emerging generative AI tools, and especially with expanding accessibility among the public, there has been a new a kind of risk of how generative AI tools and foundation models, and especially vision language models, can now infer precise location data from just images without any location metadata. So this means that even if you don't have any GPS coordinates or other location metadata attached with your image, now vision language models can just infer from the visual cues and clues in the image and to identify your precise location information. So here I am just showing a simple example, a simple experiments that I've done, with this image that I've taken from the main quad at UIUC. So I took this picture back in March, and then what I did is that I input this image to Claude and I ask, where is it? So as a disclaimer, I don't have any GPS coordinates or any location metadata attached with this image. I know that iPhone allows you to attach location information with images, but I disable that for taking this photo. So I just input this image to Claude and I ask, where is it? And I ask Claude to explain their reasonings step by step and also give the best guess for the location and also the visual clues they use. So I've listed this long response from Claude on the right, and you can see that. So first of all, Claude recognized that this is a campus, university campus, and it also points out, for example, the architectural clue. So it identified this building in the back as the auditorium in UIUC, and also identify the main quad as a major feature, and also the bare trees, and also it recognized some of the students sitting on the main quad. So at the end, it gives the best guess, which says that this looks like the main quad at the University of Illinois Urbana-Champaign, which is the correct location of where this picture was taken. Okay, so this is just one example of this kind of new risk posed by the AI tools that we have access to nowadays. And there has been emerging literature and also work documenting how these AI technologies has been posting privacy risks to different kind of data that may not seem to have explicit location information, but they can still be used to review sensitive locations and individual identities. Okay, so some key takeaway is, so again, I'm from a geography department, and in the geospatial literature, there has been a lot of literature developing methods to protect explicit location information such as coordinates or addresses. But with these new AI tools, they can now infer sensitive location information and pose privacy risk, even though your data do not have these explicit spatial information. So I believe that this is just one of the many kind of risk that can that these new AI technologies are posting, and I look forward to talk more, discuss with you more about these questions. So this is just an overview of the discussion questions, and if you're interested in privacy preserving technologies with AI and also new privacy inferential risk, we can talk more about that in the breakout session. Thank you.
Thank you. All right, would like to invite Dr. Junwoo.
Hello, everyone. My name is Junwoo, a faculty from Michigan State University. And today I would like to share this presentation talk about the uncertainty quantification. Basically, we're going to talk about how we can understand the trustworthy AI from the uncertainty perspective. Specifically, we consider like if we deploy the AI model in some open world environment, for example, when we have the new task, the new data format, or the changing environment, see in that case, how we consider the uncertainty quantification problem. So specifically, in this talk, I would like to highlight this trustworthy AI and the data heterogeneity. And in this case, generally, that's just because when in practice, whenever we want to apply this AI, it's hard to guarantee that we can expect the testing environment, the inference environment can have the same data distribution, can have the same data property as the training data we use for our AI models. So in this case, probably we should consider like how or when we should trust the AI model when we deploy the pre-trained AI model in some open world in the new environment. Specifically, generally, this data heterogeneity can include many different aspects. Like when we deploy the good AI model, like the generative AI model, to some new task, in that case, probably we will have to consider some new tasks, especially when we consider the AI for science. And in this case, sometimes we also consider like if we collect the data, the testing data from different environments, from different platforms, from different resources, in that case, we should also consider like the distribution shift between training and testing environments. In this case, we formulate as the so-called the domain heterogeneity. And another relevant heterogeneity type is about the modality. That's also very common because it's hard. Sometimes we have to train the model using the collected data, but applying this model in the future data, which could include some new data types, new data formats. And specifically in this talk, again, we are going to understand or enforce the trustworthiness of AI models from the perspective of uncertainty quantification. And currently, it has a lot of research work on uncertainty quantification, like the self-consistency. We're trying to, especially in the generative AI field, is trying to generate the answer multiple times and to get the consistency about those repeated response to see whether this model can just produce the same answer for multiple times. Or more specifically, from the mathematical perspective, there are also very powerful method like the Bayesian inference to just derive the theoretically informed posterior distribution to help us understand the uncertainty. Another relevant method is the conformal prediction, which can just produce, instead of a single point prediction, it will produce a certain region, a certain a set of predictions with the theoretical guarantee that you can always expect it to find the correct answer in this prediction set. But in most cases, it seems when we consider this uncertainty, when we're trying to inform this uncertainty property from AI models, typically, again, most of the method will just assume we consider or we assume this training and testing data set was just from the same environment or from the same data distribution. But in practice, again, if we consider this open world deployment, probably we need to consider some new data property from our new environment. In this case, the question will become how we can understand the uncertainty of AI models when we deploy this AI trained in one environment, but deployed in some new environment. So there will be two open questions to understand these questions. The first one is that how can we understand the generalization properties of uncertainty quantification methods? Typically, the reason why we care about the uncertainty quantification is just because in addition to the returned point prediction property, we can just use the uncertainty property or the prediction confidence to help us determine whether or how we can trust the AI model. Like if we can have a well-calibrated AI models, that just means if the AI models can just produce the response and also tell us it has like 70% confidence to say this returned response is correct. This 70% confidence can tell us typically when we use this AI model for our downstream task, typically we can expect 70% of the return response are correct. So in this way, this confidence score can also tell us like whether we should trust this model. High confidence is always we need. And in the context of open world deployment, or specifically, when we consider the data heterogeneity between training and testing environments, one question we need to think about, like when we deploy this AI model, how this data heterogeneity property, or more specifically, how the downstream data property will affect the trustworthiness, the uncertainty of AI models, so that we want the AI model to produce the correct, the trustworthy uncertainty to avoid this overconfident or just misleading decision when we apply this model in open world environment. And more specifically, this will involve some machine learning problem, like even though we design uncertainty quantification method to make sure that this model can be guaranteed to be well calibrated in the training environment. If we apply this model to some new environment, how can we enforce this well calibration again? Another relevant question is that when the AI model produces both the point prediction as well as the confidence or the uncertainty, in that case, how can we provide the explanations for the uncertainty? Like always, when we talk about explanation, we want to explain the model behavior, especially we want to explain why the model produced some response. But generally, if we consider the uncertainty, typically it will be very necessary to consider why the model is not so confident, why the model is going to produce the uncertainty when they generate the answer. Again, currently there are a lot of methods, especially consider the mechanistic version, or more generally consider using just natural language to help us explain the result. But overall, the open question is that how can we apply or generalize those methods to help us generate the data-centric explanations to help us understand the produced point prediction as well as the predict uncertainty. So in summary, in this presentation talk, I just want to highlight, typically in the application, we can use uncertainty as a typical signal to help us check, to help us monitor or just diagnose the AI system. And with two open questions like how to quantify uncertainty in open world environment and also how to explain both uncertainty and prediction behavior in the open world environment. Right. Thank you.
Thank you.
Right. Ramin?
Hello, everybody. I am Ramin Safo, Assistant Professor of Instruction in the Department of Computer Science, University of Texas at San Antonio. Okay. Due to intense competition in making, developing, and building stronger, faster, and more efficient. I think I should go down to do that. So yeah, I try to speak louder. Okay, due to intense competition in making and developing AI systems that are faster, more efficient, and stronger, less attention is paid to ethical and responsible aspects of AI. So we know that nowadays AI is used in everywhere. But how we can pay more attention to ethical AI and responsible AI? AI has rapidly become, it is used in everywhere, and is rapidly become transformative force in modern society, influencing areas such as healthcare, finance, education, transportation, and scientific research. While AI offers significant opportunities for innovation and scientific research, it also raises important ethical and responsible AI concerns. But we need to make sure that these concerns are considered in generating AI systems in a way that it helps to protect human rights and to promote safety and also to maintain public trust. But what is AI, ethical AI, and what is responsible AI? So ethical AI refers to design and use of AI that align with moral values, social responsibility, and legal principles. Responsible AI extends these concepts by emphasizing accountability, transparency, safety, human oversight through AI lifecycle. But there are challenges. In general, we can say 4 challenges in ethical AI and responsible AI. The first one, bias and discrimination. Biased or unrepresentative training data can produce unfair outcomes. We know that AI systems rely on data. They are trained by data, okay? But if we have biased data, so the outcome will be unfair, okay? This is one of the challenges. The other one, transparency and explainability. Many AI systems, particularly deep learning systems or complex deep learning systems, function like black boxes. Okay, so users cannot understand how they make decisions. Okay? So black box decisions can weaken trust and accountability in high stakes settings. The other one is privacy and data protection. Personal and sensitive data requires safeguards, secure management, and user control. Many AI systems need personal and sensitive data. But if they are not protected, they can be, or in a good way, they can be misused, proposed, or exploited. And the last one, but not the least one, human oversight. AI should support, not fully replace human judgment in critical domains. Critical domains such as, for example, healthcare or criminal justice or national security. It shouldn't be fully replaced by decisions that are made by fully autonomous systems. Still, we need human judgment. Okay, but how can we respond? So we need diverse data. We need to make sure that the data that we use to train our model AI systems are diverse data to reduce bias. Explainable AI to interpret decisions. Privacy safeguard is very important to make sure data is protected. Regular audits, it needs to be checked through the life cycle of AI, not in the beginning or at the end. And human oversight to retain accountability. Okay. But is it responsible only for one of, the entities? Is just responsible for government or industry? No, it is a task shared between all of them, but each one has its own responsibility. Government should establish regulations and standards that promote safe and fair AI while supporting innovation. Industry should adopt responsible AI frameworks and conduct regular audits. Researchers or research institutions should develop methods that improve fairness, explainability, safety, and evaluation. And education, academia, professors, instructors should prepare students and professionals for both the technical and ethical dimensions of AI, not just technical and ethical dimensions of AI. So what is the global goal? Inclusive access and equitable distribution of AI's benefits. Okay. So again, AI should serve humanity in a fair, transparent, accountable, inclusive, and beneficial manner. So these are what we need: fairness, transparency, privacy, accountability, and inclusivity. And the breakout discussion questions. First one, where should responsibility lie when an AI system causes harm? That is a very important question. Are they developers, organizations, users, regulators, or some combination of them? Okay. And the second one, how can we balance AI innovation with fairness, transparency, privacy, and meaningful human oversight? Thank you, guys.
Okay. All right, let's welcome. Yeah.
Okay, good morning, everyone. So I'm going to talk a little bit about how some of the work I've been doing with iGuide and some of the findings from that, and in particular, focusing on how you actually can embed responsible AI practices within AI workflows, AI-driven workflows. Okay, how do I move on? How can I move it on? Oh, there we go. Sorry. Okay, so there's been some progress already towards making research more ethical. There have been many measures taken. I want to highlight, for instance, the FAIR principles, which you've heard about yesterday, making data findable, accessible, interoperable, and reusable towards which provide a good set of standards against which progress can be measured and also provide goals for evaluating the extent to which data and models are shared in a way that makes them truly reusable. I should also mention the CARE principles, which I forgot to put on the slide, which are the CARE principles for Indigenous data sovereignty. I just want to say the E in CARE is for ethics. And so there's some work there on guidance for how to implement ethical practices for certain types of data in certain contexts. There's also, of course, policies for making research workflows more transparent, such as data management plan requirements and open science requirements by funding agencies. And the FAIR principles, compliance with the FAIR principles is a great way to ensure compliance with those mandates. And then as well, there's also developing tools and toolkits for specific scientific applications, such as I just want to give a shout out to Image Genomics, who have created some really good documentation tools for realizing FAIR and also that explicitly address ethical issues. And as well, just to plug, been working on the iGuide Data Ethics Toolkit, which has emerged out of long-term social science research with iGuide platform users. So a lot of progress has already been made. These measures have helped to enhance transparency and accountability. They've helped to normalize the idea of creating and maintaining documentation. And they've helped to move responsible practices from sort of being an afterthought more to something that researchers can actually build into their own workflows. But many challenges remain. So the first question is, we talk about accountability, and the FAIR principles are very much raise the question of accountable to who. So FAIR can make a workflow more transparent to other researchers in particular. But what about other groups of people that we might need to be accountable to? For example, if our research is used to inform policy decisions, then policymakers very often really don't have the technical chops to really kind of understand detailed documentation, various different terminology, that kind of thing. So they need something that's more, being accountable to them requires something different from being accountable to other researchers. The people who might be affected by these decisions, or maybe products that have been developed from research, they need to understand, if there's harm, they need to understand how and why decisions were made, but also to identify and ensure accountability. And community groups who may find it very useful, sort of activist local community groups, for instance, who may find the data useful, but they need to firstly be able to understand what the data's potential is, and also how to use it. And of course, these groups of people don't necessarily have the same level of technical and jargon knowledge to understand documentation that satisfies FAIR. I also want to sort of highlight as well that FAIR is kind of takes us part way towards full transparency and accountability. Currently, it does make workflows more transparent and more open, but at the same time, there are sometimes tensions between FAIR and ethics. In particular, currently, the oversight for ethics is primarily institutional review boards in universities. That's kind of long-standing in the social and medical sciences. And that's really focused when research is collecting and using non-public data about people. And also, there are a lot of policies, legislation, etc., around some categories of sensitive data. But at the same time, there is kind of a lack of oversight or a lack of enforcement of many aspects of the ethical questions posed by AI. For example, data that is non-sensitive and non-human subject, there are still considerable reuse risks in that data. In particular, for example, combining data sets can be a way to sort of de-anonymize data, or to identify people and individuals. What was I going to say? Yeah, so there's that. So in particular as well, ethics lags FAIR in many ways. Basically, there's been a lot of research around how to make data more shareable, more reusable, going back over 2 decades plus. Whereas, and there's policies that I mentioned earlier, enforcement, there's community norms around expecting reproducibility. Reproducibility has long been held as the gold standard of science amongst different disciplines, but as I said, sometimes outside of the social and medical sciences, the norm of research being ethical isn't so well established, because people have always thought about human subjects data primarily. The incentives don't really exist as well, because again, there's no real the penalties for not complying with ethical standards are kind of much more ad hoc compared to, say, the NSF deciding if you've actually fulfilled your data management plan, and the infrastructure as well. So when a researcher encounters a trade-off between fairness and ethics, what do they do? But there's no real no real answer to that question. Yeah, okay, I need to wrap up. But also as well, FAIR does sort of orientate people to think downstream. So it's about making your own research more transparent to the people that may use your research outputs. But at the same time, and this is what our research with iGuide has shown, is that actually That's great. That's very important. But also, you need to look upstream. And we found that researchers who are using data and models others made, for example, from big institutional infrastructures like the US Geological Survey, they don't see how the data is being collected. They don't see how it's being produced, and instead they have to trust that it does fulfill ethical standards. And people who are outside of the discipline may be using data from another discipline. People may they may just more likely to take the data on trust. Seniority. So if you're a doctoral student and your advisor has said, use this data set, you're not necessarily in a position to argue back too much. And pragmatic considerations. People have to trust data if they want to use it. And if they want to get their publications, get their PhD, then they have to use data. And it's not just trust in people, but also trust in the institutions, like I said. And then okay, very quickly. It was also this question of what should be automated and what shouldn't. I think it's fair to say that a large bureaucratic documentation practices is very time-consuming for individual researchers, and it may conflict very strongly with their priorities and slow research down. At the same time, so automation can be very useful. It may also ensure standardization and comprehensive coverage of ethical issues that may not, an ad hoc approach might not take. But at the same time, do you really just want to outsource everything to AI, essentially? Should AI grade its own homework? And so that's the final question. And thank you.
Yep. Right. I think we just go down the slide.
Have to make it full.
We cannot do a slideshow, so you can just go down the slide.
Oh, no. Can I make the full, enter full screen?
Yeah, see the work. Okay.
Okay.
Okay, this. All right.
Hello, everyone. My name is Smita Dharmura, and I am from ACER, UIC, which is Research Computing Center at UIC. And by training, I am a physicist, but now I help UIC researchers to use our, all the computing resources. So my today's topic is the reproducibility in scientific workflows. Specifically when we can see that AI is more and more happening into our work. And I want to talk about the challenges and the path forward. So I just want to ask a simple question, what we can do so that the results we produce, anyone can trust and also rebuild that. And just want to tell, as I mentioned that I am by training as a physicist, so I am a particle physicist or high energy physicist. So I was associated with the Atlas experiment more than a decade. So I experienced that, or I understand the importance of this reproducibility. Like in our field, if you are doing something elementary, looking for new physics or something, it's important to anyone can also reproduce the result. So that's why I chose this particular topic to discuss. So I would like to start with a very this example actually from the last week. This is a very recent kind of article. So there was one experiment which was led by the SLAC and the Stanford lab, and in that lab, so they have the 4 lab, and they ran the same experiment to make the training data for the AI model. They did everything exactly the same, but they got the 4 different results. And then when they tried to dig what happened, like why this, and the main cause was something as small as how hard they stirred that material. So that was the only, because no one written down that one, no one documented that part, and only because of that the results were different. Of course, then they changed the results for this. So the conclusion is very obvious by them, very simple but very important, right? The reproducibility is the key to the AI-driven science, and small unrecorded details can break it like very easily. So this example is just about the data we are feeding to the AI. But my question is, what about when the whole AI is one doing the whole work, not only the data? So. One of the reason to all this problem, what I think is we mostly save the answer, but we lose the process. So what we record in journal is like data, code, software environment, those kind of a thing. But if AI is playing an important role, our results are also affected by the prompt, the model version, AI raw output. Once we are getting the output, how much we are taking, how much we are rejecting, all kind of this. And there are a lot of studies. So I have these other references. If you want, you can check. So someone did the experiment, like the same experiment 100 times. So they give some code to the one of the AI agent, to auto generate the full codes. So it did, but only 68.3 time of the AI generated code ran out of the box. And there are a lot of other studies where it says the process goes under unrecorded, and all of the papers research are coming. We don't see the process, or we don't see what's happening, the prompt, the model, and the version. So, and the consequence is you can rerun the code but still not know how the results was really made. So it's very difficult to sometime to trust. So what is the cost when we lost this process, or what's happening in between? No independent check. One of the very important point, it could be like others cannot repeat your work. So of course it cannot verify. Then no traceability. So without a clear record or without any steps, so error cannot be located. If you have any bug, then it's very difficult to right? And then of course no reuse or extension. You cannot build anything after that, right? You cannot have extension based on your previous result if you don't have the whole process recorded. So this process of reproducibility, or the process of all the documentation, it's not just just the documentation. I think the reproducibility underpins the verification, traceability, and the cumulative nature of the science itself, because these things are very important: checks, traceability, and to reuse or extension. So just based on my experience to do some literature survey, I think there are some path forward. So I actually have like a 3 record, automate, grade. There could be more, but I am summarizing in 3. So record the checks, not just the code, right? How the AI steps were tested so other can judge them. I have reference, then make it default. So platform should capture this automatically, because researchers can do, but everyone, like maybe from the STEM background, any other, they are not here, to do the computing and all this. So maybe it could be a responsibility of the tool we are using or the platform you are using, but make it default and then set a bar. And this is, I'm taking the example because it's already been doing, I think in the life science, the researchers already set the bar like a bronze, silver, and gold, and it based on how much documentation you have. So I'm just giving this, so how they have decided. So this is the paper they have mentioned. So bronze is when you have only data, code, model output shared available. So most of the AI assisted work is bronze nowadays, but they have like silver if you have bronze plus environment, then all of the record, and then someone could actually rebuild. And then they say like if it's gold, other than bronze, silver, and then one script that reproduces everything, raw data, and automatically run and clicks all guys kind of a thing. And just one example, like these kind of a thing works. So this is just an example. I think in 2022 Neuro IP, this conference, they added the eligibility criteria. When you submit the paper, you need to add your code as well. And after this, the code sharing was increased from 50% to the 70%. So we can see the habits, the tools are already there. So we can also do with the AI assistance and not only the code, maybe all other documentation. So this is just one example I'm giving. So at the end, I would like to say that reproducibility must evolve with the AI. Now AI is part of our science. So right now we are just saving the process, not the, we are losing, we are saving the answer, but we are losing all the process. So it's important to be save the prompt models and everything, not just the data, not just as the code. So maybe in the last, after that, I would like to hear your stories based on the background, the breakout session. So these are my questions. It will be in the Google Doc as well. Thank you.
Thank you. So, Aman, when should we come back? And 11, half hour, 12. But Peter need to leave at a time.
So let's say 25 minutes.
And-
Yeah.
11:55.
Yeah.
Okay. All right. So this is the breakout room assignment, and we'll be putting everyone back here at 11:55. Okay. All right. Okay, let's go.
Make that bigger so we can see the room.
The room. The best I can do is to slideshow.
So the one with UA down the hall, 206.
Yeah.
UA
Yeah.
206 down the hall. June 213 down the hall, right, and then a little bit left, you'll find there, and then the other two are right here. I think there's yeah. Oh yeah. Group C is here. Oh yeah. Group C and
Oh yeah. There's a flip. Sorry. Yeah. I can fix that.
Okay.
Yeah. So C and D just stay here. Yeah.
Yeah. Yeah.
And I believe you will grab on the corner, right? So if Smita took that corner, maybe you could took the corner back. Yeah. All right.
C that corner, D in this corner. D is out. Like so group D will come here, group C, follow Peter, group D here. D is down the hall, right?
I just wondered where these. Oh, no, sorry. Yeah, you know what I'm. Yes. It sounds like too interesting. Okay. Yeah. No, there's like everything that you I'm seriously. Versions of that. Yeah, yeah. And then maybe I just won't say that. Still. I don't know there for 3 days. These things aren't new. Yeah. Also, oh, yeah. So that's what I said. All the time. I'm going to say, First. Thanks, and that's important to way now, be able to produce it. It's a great question. Not good luck. Why and it does. And not the better. I think that one thing was right. So well, that passed. The people yeah, that's good. All those questions. Is that answering the question?
Now I know it is, but and I'm never saying what I'm going to say. It's not it's like yeah. And what they're going to do is all saying
because there's just something like also the two record history on the conversation. Otherwise, there will be both text.
Sometimes all this is yes, steps that says so nice. When I did my program, so it's not number.
Oh, that's good. Or
so sure. If it's an answer to what we did with assumption, sure. Basically, the conversations, maybe the conversations. So one thing I've heard from say You said a few things there. Well, one thing that I heard you say, we're talking about after surgery, it's kind of I think that the one key division is that we have to do maybe that's option. Both last what's the things to actually you know to say this was very So this is one about their principles just operating over they can also it's also I see the overlap and you're right, it's not because how would you pop out of I see the next question. You should be responsible for ensuring these.
Or like taking the whole steps.
I'm biased, and I'll just say, creating a platform in the AI tool should never be responsible for everything. It should never be responsible because these things should only be responsible for. So, and that's like we push the responsibility to the AI tool. Or it could be checked. He's ready right now. I change next week. But so I would say that's responsibility of the researcher to ensure the research. So did you think that going to what Jerusalem was it more easier so responsibility researcher to make sure that's sanity check and make sure it works, make sure that it's but I think it I was thinking I was thinking to be work fast like use agents I very hobby I don't think that I agree running actual data or all the things in that replication but they had so expensive. You know, I don't think it's a risk. Yeah, exactly. All clarify how
Somehow we have one project that was very selected from different backgrounds. They took the so we got different we have to walk through it. So that they can
So review that, super, right? Because the instruction for this, a lot of expertise. You were saying the process, when you deduct the process, how you actually appropriate each study and any issues, I think you actually have it. Or the first one and then the second but before it's all but other the other incident you don't want to go up and then the doctor say the thing but so they I think the answer that the communication was necessary and we not get one I'm not really I just find where AI, you know, it's not just necessarily AI, we have sensors, any number of things, so researcher. So we think we're not entering. It's the actual method. I think you have to switch it up. But we're going to attempt to use of AI tool for our information. That's for these things to put off to the back. But many possible, they don't need well, I was just thinking whether they didn't have you essentially was like that's what like so yes, thank you also for some of the part but they will
And so that, yes,
Let's see. Your first question, I have the central. I. And that's not all of it. It's very good concept. You guys understand that people understand. Very good. And.
Yeah, more, yeah, so it does, yeah, I do, sure. Well, the. I know how to do it. Yes, I think you saw it. What is the. Llenas the researcher, they our. So it's two things. How that first, it's not. Yes, so. Someone just culture, so well, I think that whether it's have a but then there's a where that high salary is still the same. So, but then it will start and I can have all the measures of these things. In the end, you know, like, and now it's well, yes, there's they're different. So I love like so great, so even on the there's actually one, so that's what very nice. I'm not saying it should, I'm just saying that's the question that so it's yeah, that's you belong to actually like just be
So I just hear like, making sure that it works is fully, so water dimensions, so that also we put that. As a line that there. Yeah. So visionary, something.
All right. I want to draw everyone's attention. We are going to do the concluding report, and we would like to invite the lead to appoint one of our representatives to summarize the discussion in your group. And due to the time constraints, so we can only allow to make two takeaway points. And we'll start with I don't know, Peter, do you want to go first? Peter, yeah.
I just sat here.
Yeah. Yeah.
Take a mic.
Oh, that also work, yeah. I think you could just come up here, right?
Alright.
Yeah. Because Peter is time constrained, therefore we will start with team C. Two takeaway points.
Sorry?
We want to catch back our time, so each team can only make two takeaway points.
Two takeaway.
Yeah.
Okay, so our discussion really revolved a lot around responsibility and the challenges of assigning responsibility when you've got this huge system that involves lots and lots of people and lots of different moving parts. Things that may go back a long way in time. Decisions made about data, how they were collected all the way through. Perhaps historically, because that's building on models that build on models that build on models that build on models. And so it's very kind of easy for individuals not to feel responsible, but then at the same time, if you go too far the other way, how do you distribute accountability if everyone's taking decisions that have some impact or maybe a minor impact? Yes, they should be responsible, but at the same time, they're not fully accountable, and that's a big challenge as well. And then we also talked about care principles more, which I only very briefly mentioned in the talk, looking at how that really gets to the heart of things like who owns data, not just who is responsible for data, but actually who owns information, and kind of getting away from the idea that maybe evidence data or information and knowledge is there to be plundered, but actually it does require that much more nuanced framework. And we also talked as well about existing frameworks that exist, say, in particular domains that maybe even happened before AI, such as medical device regulations and accountability frameworks, and they might provide a good way forward as well.
All right, thank you. Right.
So we are Group A, and we talked about the privacy issues with AI and also ways to safeguard privacy in the era of AI. So one thing that we've talked about is the tension between potential usefulness of using AI to infer information from the data we have. So for example, with location data, it is useful to use AI to identify locations for wildlife tracking and for other purposes. But there's also, on the other hand, there's also privacy risk arising from using AI to identify sensitive locations from image or text. So that's just, the first point I will talk about. The second point we talk about is what are the practical ways to really help safeguard privacy in in the age of AI. So we talk about different things. So specifically to location data, one thing that can be done is to, so in my previous presentation, I talked about the geomasking methods that can be applied to explicit location data. So with the implicit location data that's buried in images, one thing that can be done is to apply different levels of, again, masking techniques to mask the potential visual cues that allows AI models to make inference. And there are also potential ways to develop models to inform users. So when they're posting images or other contents on social media platforms, there can be a tool to just help to inform them what is the risk, what is the privacy risk of you posting this content. And the users have a choice to select whether they want to share the information or not. And yeah, I think that's all.
Yeah.
Okay, thank you.
Thank you very much. All right. Group B.
Hi, we are Group B and uncertainty and reliability. So there are two most important takeaways that I want to share. The first one is that when we talk about the uncertainty quantification, one key challenge is that how we can apply the trained AI model on the out-of-distribution data in that case. And currently, the prediction uncertainty will be affected by such kind of distribution shift. But a more challenging scenario is that we will talk about the large language model or on general text data. In that case, even more challenging scenario, even important challenge is that how we can estimate the distributions in using the input and output token. But on the other hand, in addition to this kind of challenges, this uncertainty also provides a good opportunity for us to understand data. Like we can just consider the connections between uncertainty quantification and anomaly detection, like using uncertainty quantification techniques to help us estimate and remove some anomaly data. So it's more like a two-way steps, two-way things for the uncertainty. First of all, we try to understand to consider whether we should trust the AI model, especially when we have the out-of-distribution data in the open world environment. Secondly, we can also try to use this kind of uncertainties as a very useful tool to help us detect and remove the possible anomalies. Yeah, thank you.
Thank you. We have the last group.
Hi everyone, my name is Ryan, give your report. So discussing reproducibility in AI-assisted research in Group D. Right now, if someone tried to reproduce your work, they would likely be missing critical details like exact environments, package versions, hardware specs, and the actual back and forth interactions researchers have with LLMs, especially what AI outputs were discarded and why. To fix this, we need a centralized reproducibility checklist that details every step and establishes clear benchmarks for knowing when a workflow actually works perhaps borrowing from documentation best practices in industry. Further, while the heavy lifting of tracking these details can be handled by AI tools or computing platforms, the ultimate responsibility for ensuring the work is fully reproducible remains squarely on the researchers and the research team. And then in the spirit of this, we took notes in the Google Doc, then we used Gemini 3.1 Pro to submit notes that prompt, write up these notes in a short paragraph for a short report. The report was validated by group lead. If someone uses a different model, let us know.
All right. Thank you everyone joining this session. Let's give a round of applause for everyone participating in this session. And then? Yeah. Do you want to announce when we should come back? Thank you so much, everyone, for staying engaged. So this is lunchtime. We have lunch outside. We'll come back at 1. We have 2 breakout sessions in the afternoon, one at 1 p.m. and then I think the other one after that. So we'll figure that out and we'll share more details with you. So go enjoy lunch and come back at 1. Thank you so much. Thank you. Thank you so much. That's retired. Oh, yeah, that's semester. Okay, that's how that makes sense. So did you already reach out? Which I Oh, it's a nice thing.
Yeah, I'll just. I must have a higher looking space. Even if it's not. I think it's also very nice. Was I feel like one of these also it was so that's very scary. The revolving.
So we never know what I think it's gonna be.
Yeah. Yeah, so yeah. Not ten, but actually for but $24. And I'm not too much.
If you're waiting on this, we're all in. This last thing, should see. That's also.
But this is the advantage of. And basically. Such a that's why they're. That's what those ways. Now they so really it's very good. They basically.
I essentially got here before I did reader right. That was a civil saying 4 years ago. I did stage where I had to die. I got I'm trying to see for that and how did my 3 years is enough. I couldn't find today something. This here. How many were Wow. Yeah.
It is not money for you.
Yeah, the link shows, the way it's set up. Yeah, we're still pretty involved in the model. But So this year, I think are you? That's really that's part. So that's I have basically one of my classmates yeah. I eventually looked at that it's not a single model to be outside the air or something. I don't know, it's there's so many where and they're both in this thing. So it's not that easy. I really look this down. So once you're ready to sit the busy down. But if you know it's so it's really the one part you guys that want to sit you're younger. Yeah, there's oh, okay. So far. I was not Very nice talking to you too, bro. We see you. I'm glad that you back me down this time. Like the evaluation of students. Oh, so code actually not changed. It's just that they don't something along, they something. So, second, But it's the same.
So we're gonna try the to be on the buffer and in the town. So yeah. It's like now each county itself subject associated to home. It's not that so challenges giving shots. There are and social. That's no, what I just said about this. I see the value. Execute service. That's a simple. Yeah. That's yes, if you get that's. Yeah, okay. Just go show.
Yeah. Here's an example. And then it's up to you last. So I have 5 minutes. You have slides, right? I do, but I'm losing. I'm not sure about that.
So, yes.
I did not go to. Yeah, I think you're. This is just. At the top, the moment. I was I know the ones who look at the stage. And it's a lot of stuff. You have to take. Just like. So. That's what. Yeah. So that could probably involve. And then just get on to. And then you can understand. I would say, oh, yes, and then so whatever. You think they'll be. So that's the problem with that. So what you're saying. Because they can change the day, it's safe. So they just some there, guide them, stays, driver. Yeah, I love this. Yeah. And give them all a short period to be a impression of that. You got to shape all this. No,
that's fine. Let's see, we have the one for convergent science for disaster. So we have.
You can do it too, right? It's just like, this is just the announcing,
Yeah. So
getting people's attention.
do you want like, there are 2 slides.
Okay.
So this, yes.
My job is to advance the slides, right?
You don't even need, they will do that.
They will do that.
Yeah, so they will do it. It's okay. You just keep them on time, I guess. That's the only thing we have.
Okay. But we're talking about disaster, right?
Yeah.
Yeah. I'm just saying the.
Yes. So this will be great. Yeah, maybe this needs to be downloaded. It's kind of like.
We can switch to it. It's okay.
Yeah,
I can switch to it.
Yeah. And then,
it's no worries.
So let's see what the.
Yeah, we need to do. We need to download this.
This one, I think.
Oh,
maybe
the scan position backup.
Is that no? I don't know what back. Oh,
No.
that's that one. Sorry, this one. Yeah,
Sorry.
we need to download. Yes,
The scan.
Yes. No.
Oh,
Ertican, yeah.
Ertican. Okay.
Ertican data.
Okay.
Because
there we go.
PDF. Boodoo's, maybe we need to download his PDF as well.
Okay, that's one. And then Voodoo.
Yeah.
Okay.
That's good.
There's Ertican and there's Voodoo. Okay.
Yeah, but the rest we can just run that, right? Or
Yeah.
just open it.
Yeah. Yeah. Okay, so let's see if we can open them. Okay, cool. Two. Okay, cool. And grab this. Okay. In whatever order, right?
Yeah, whatever order they
Whatever they're open.
yeah,
Okay,
they can switch.
yeah, okay.
We can close the others so that they don't get confused. And we do have a notes directory as well, so then to take notes, yeah, that's the order, close it.
Okay,
Yeah, you can-
okay.
That's it.
But are there any intro slides? Oh, there, no.
No, that's it. We have all the slides now. All
Okay,
five, right?
but-
One,
yeah.
2, 3, 4, 5.
Yeah, but do we have intro slides? No,
No,
no.
no, we don't. So go to notes or something. Yeah. But there's nothing. So maybe we'll create.
Yeah, let's do
direct-
that.
Let's create a notes directory.
Let's do, yeah, let's do the notes directly. Wait. This was not, we can do in the same directory as before, no?
This is for this group. Yeah, I guess.
Oh, okay.
Maybe, yeah.
Let's do the same one, no?
No,
As
let's-
before? No?
Yeah,
Okay.
let's do it here. Like just
Okay. So, folder or,
file.
Oh,
Maybe
file.
we'll then make
Okay.
tabs or something.
yeah. Okay. So
Just, yeah, great. What one?
notes and then tab 1. No. Okay. Oops. Okay.
We need 3 only, right? I think how many breakouts do we have? I think one of them was an undergrad, so I combined it with the someone senior.
Okay. So what are the names? Just give me the names and I'll rename them.
Names of what to do.
Breakout.
It's one.
Just give me the, can you read out the names just so I
What
could,
is like the author, like the people name or the
the breakout.
we just how do you say? It's breakout A, B, C, D, and
Ah.
they have the okay.
Oh,
Okay.
causal.
Causal generalizable.
No, sorry. This is the breakout groups. Okay, group out causal and causal AI. Okay,
Causal, yeah.
okay. This one
Then
is
time critical and disaster support.
time
Critical
critical
and disaster support.
disaster. That's good.
Okay. Third one is Earth system dynamics.
Yeah. Okay, and
That's it.
that's it.
That's it. We just have to.
Okay. Okay. Actually, let me write down. So group A where?
Group A, that would be 206 AB.
206 AB. So that's causal. Group
Yeah.
A causal.
Causal.
Yeah. Causal.
And
Okay.
okay, yeah, that's fine.
Then the second one is time. Group B is time
Where
critical.
are you writing this? I think are you writing in the
I'm gonna
oh okay.
delete.
Yeah, that's fine. That's group B. Time
Critical, yeah. Where?
213.
Okay.
AB. 213 AB. So
And then group
third
C is the system dynamic is here, right?
yeah, that's system dynamics. Okay. Yeah, this one.
Here. Okay.
That's it.
Okay, so okay. And then no problem. Thank you.
Okay. Get your coffee now. You had lunch? Some conversations? Time to start thinking again. All right, don't leave the room. This is not yet. All right, since we're at about half of the number of people we started with, that means everybody has to think twice as hard and be twice as creative.
right? So with that, I would like to ask all the position paper speakers, all 5 of you, please come up. Do you know who you are? 5 position speakers for the afternoon? 5? 5? Yes. What? Come up. Like, come up, line up. Yep. Right? So we're going to do the same thing as we now all have learned before. Before we do this, everybody else, do me a favor, get up. Get up, get up, get up, get up. Get up, stand up. Yeah, we've been sitting for very, very, very long time. Even if like just getting food was not enough, right? So like show me how much are you enjoying this meeting? That much, right? Hey, how much would you like to come back to Chicago? That much. Yes. Right? How much do you love data? That much, all right? Great. And if you feel up to it, jump up, right? Get your energy going. Right now you can sit down or stay standing. You're welcome to stay standing. We're gonna do this. So 10 minutes, right? Each talk is 10 minutes? 5. Okay. I will be like really. So in the order in which the tabs are open, graph based.
Hello, everyone. I'm Molly Balkin. I'm an undergrad at UMBC's iHarp, and this is my work on the graph-based detection of spatial linkages between sea ice retreat and ice shelf melting over the polar regions, which is a very important topic because if all the ice in the Antarctic region melts, the sea level stands to rise by 200 feet. And given the fact that 45% of the global population lives within 100 kilometers of the coastline, and 45% of the population would stand to lose their homes. The ice sheets they've been retreating at 130 gigatons per year since the year 2000, and land ice is surrounded and protected by sea ice from thermomechanical forces, but that ice has been retreating since 2015, attaining a record low in February 2023 to 2024, reaching 32% lower than the average. And in the past, the ice sheets and the land ice and the sea ice have been studied separately, and the connection between the two and if the melting had anything to do with each other had never been explored. So my group wanted to bridge that knowledge gap and see if they should be studied together. There's supposed to be a picture there. Basically, we used over 2,400.
Okay, good. No. Okay, describe it.
Okay. I'll do my best. This might be a bit rough. But so we used over 2,400 satellite images from the year 2000 to 2020, and we separated the land ice and the sea ice, and then each spot was like a node, and then to set up the edges between the nodes, we used Delaunay triangulation, and then we did breadth first search, so they were all going directly to their neighbors. And there was a boundary between the land ice and the sea ice. And then we did Monte Carlo simulations to make sure that our connections had significance and they weren't just random. So this is an example of 1 week of output from 1 year. I used this specific graph because there's actually 2 of them connected. But if you can imagine this, and this is just one scenario from 1 week over 20 years, together would have been a lot. So we had to split it up into all these different scenarios. And so we did median to Q3, we called that low. Q3 to upper bound was high. Anything above upper bound was anomalous. And so then we set up a matrix from left to right. It's low to anomalous sea ice retreat. Top to bottom is low to anomalous ice shelf melt. And
as you go to the more anomalous situations, there's a lot less connections, but we actually noticed that the graphs were getting bigger. And this was the same graphs, but in the box and whiskers. And again, you can see there's a lot less dots in the anomalous situations. So yeah, mean and median were going up along with IQR. The total and the range are going down, but having the high IQR in the anomalous situations indicates a greater variability, which means that the two are very interconnected. We also looked at the direction, and we saw that the melting starts in the ocean, moves directly towards the coast and ice shelves. And there was a loss of connection in the extremes. So if there was an outside element like weather, you would expect the change to be the same. That wasn't the case. So it was very clearly one affecting the other. And this was over the Greenland region with different variables going on to prove our method was robust. And we still got the same type of graphs. And altogether, these findings suggest that sea isotropy is an active driver of downstream processes of shelf melting. With increasing melt or retreat intensity, events occur less frequently but exhibit broader spatial coverage. So the cryosphere is highly interconnected, which underscores the importance of the novelty of using graph-based framework. And then future directions, we could look at the causality. Why is only happening in certain areas? On the graphs before, it was only happening it wasn't happening at the Ross Sea, but was at Weddell and the Indian Ocean. And then we could also use the same great fast spatial linkages to look at other domains like animal migration tracking. And these are some open questions for the discussion later.
Okay. Next one. Wants me to enhance the slide, I don't think.
Hello, good afternoon, everyone. I'm Imam Hussain. I'm a PhD candidate at UMBC and also working as a research assistant at IHUN. So today I'm going to talk about moving beyond correlations of typical machine learning model and how causal AI can be used for generalizable earth sciences. And particularly, I will argue that more features can mean worse sometimes if you don't understand the features. And what transfer is the mechanism, not the correlation in the data set. So we see that a model can be right for the wrong reason. If you don't understand the model, it can be sometimes give you right answer, but for the wrong reason without understanding what's actually going to happen. So for example, think about a lake, superglacial lake, which are like meltwater body on top of ice sheet. And if you look at the model on the left side, so we have a lake on southeast Greenland, and it melts during the peak July sunshine. So the model see that, okay, during mid-July, you have peak sun, and you also have peak melting, so it drains during that period. And what the model runs is that, okay, it's mid-July, and the ice looks dark because of the melting, and the lake drains during that time period. So we have a trained machine learning model here. And if we want to test other regions, for example, Northeast Greenland, probably the melting season starts a little bit later, not mid-July. So your trained model fires during the mid-July season, but actual drainage happens probably mid-August or later than that. So the model cannot capture these changes because you train the model in a different scenario. It cannot be generalizable to other situations. The actual mechanism it missed is that you have sustained warmth, which accumulates meltwater, where the pressure builds, and then this pressure makes ice to fracture, and finally the lake drains. But you see, the model still gives you some good accuracy, probably 80%, 90% accuracy, but you are not understanding what's actually happening inside the ice drainage or lake drainage. So that's the focus of causality, causal AI, where causal model keeps less features, but keeps the one that matters. So you have this traditional correlation-based model where you collect some features and you train them, you train the model using all the features, whether they have some significance in your problem or not. And we choose this feature based on availability, but not based on any evidence. But in causal models, we can use causal discovery techniques to find some causal features which actually have some cause and effect relationship with our problem that we are trying to solve. And we may get a subset of small features which are important, which can be sometimes global across different regions or sometimes have some specific region-specific features. For example, in Greenland, we have like different regions, 6 regions of Greenland. So some of them are global across all the Greenland. Some of them are like region-specific feature set. And also these features can also have time delay. So warm today does not mean that the lake will be drained today. It can take some time to accumulate meltwater and then ice fracture and then drainage. So these causes can take time. And we also accumulate this time delay as well in our causal model so that we can capture this delay, which is physical and can be transferred across different regions. To see the hypothesis actually works or not, so we used a superficial lake classification model where we have 1,000 labeled lakes of 6 Greenland basins into 2018 and 2019 melt season. We classified 4 different types of lakes, buried lake, refreshed lake, and 2 different types of drainage events. And we did traditional machine learning split, like you have the full data set, you train the model on 80% data and test on 20% data. So we only got 1% accuracy gain over the baseline correlation model. And we went a bit deeper into the in-distribution setting where we trained the model on the same region and tested on the same region as well. So we split the data into 6 region-specific data set, and then we trained the model on the same specific and then test the model on the same specific region. But the main point here of this research is to see how the model performs in out-of-distribution setting. So in the last one, we trained the model on 1 basin and tested the model on all the 5 other basins. So which means that the trained data and test data is completely separate. And we can see the accuracy gain is across all 6 regions. We have 2% to 12.6% accuracy gain. And even if with a smaller set of features, we get accuracy gain across all the regions, which is a good news for causal model, because even if you use less feature, if you understand the mechanism, then it's better than traditional correlation-based model. So I leave 3 questions for our breakout session. So currently the out-of-distribution testing is an ablation study. So my question is, should this testing be a requirement instead of an ablation study? And can HDR Institute standardize this process for their research? And can most labs even afford to do this, because causal discovery in large scale is very time consuming and computationally expensive? Can we build it for once and can let everybody use it later in the next iteration? And final question is, like, the causal connections that we get or the causal graph that we get is based on some hypothesis. So how do we validate that this is correct or not? And how can we include domain scientists in the loop so that we can actually verify the knowledge that we get? Thank you so much.
Thank you. And moving right on, wildfires.
So imagine the next potentially catastrophic wildfire, the one that will be used to test your model. It isn't one like your AI has already seen. It's the rare event that crosses scales, lacks observations, falls outside your training data, and forces decisions before anyone knows whether the model is right. No pressure. Wildfire, therefore, gives us a brutally practical test of AI, not whether it performs well on familiar cases, but whether it's learned enough of the underlying system to hold up when the real world becomes unfamiliar. That test reaches the questions at the center of our meeting. Do our data sets represent the problem? Do our models capture causes or merely correlations? And will our research infrastructures reveal failure before the deployment or only afterwards? Goes?
Yeah.
Thank you. So wildfire is clearly an interdisciplinary problem. We have to work together from many fields. Many of us are from physical sciences, fluid dynamics, math, but we work with the life and earth sciences, forestry, ecology, and also people from human and behavioral systems. We don't approach knowledge the same way. These different traditions ask different scientific questions. The physical sciences, we use governing laws, natural physical laws, physics-based models, controlled experiments, whereas people from the life and earth sciences, we find they learn from observations and often use statistical inference. We also had different traditions about what evidence is and causality. If we look at the features why a fire behaved the way it did, I would often attribute it to weather and terrain. And while people from the life sciences would attribute it to fuel structure, whether it was treated in the last 10 years or so. So if we approach this as a convergence challenge, we have to combine mechanistic models, observational learning, and human decision processes in our cyber infrastructure. So why this is difficult? Lots of reasons. One is a data problem. Extreme wildfires are rare. If we look back in the history of fire activity, our satellite data goes back to 1980. There are a few days per year that support large wildfire growth. Of the fires that occur, only 2% ever grow above 100 hectares. Yet the largest 1% of fires account for 80 to 96% of the area burned. An exponential size distribution often fits the size frequency over large data sets. The wildfire record is also a biased data set. So 98% of ignitions are suppressed. And thus the observational record reflects management as much as nature. The ones that are suppressed are often accessible. They're slow growing. They were detected early because they were near populations. So most fires never become disasters. And I can tell you from personal experience, extreme events often occur precisely where observing networks are sparse or absent. An example is in the lower right. This is the fire that tore through Lahaina. There was a wind event approaching the northwest part of Maui, and it caused extreme downslope winds. Yet when we look back at this event, there were no weather stations anywhere on the downslope side of that island. And we're trying to reconstruct what the wind structure of the winds were. Did it cause this or that? There's absolutely no data whatsoever. So why this is difficult? The process problem is another issue. Wildfire is a multi-scale gated process. Wildfires require the alignment of a large-scale underlying susceptibility. You'd think of hot and dry, but it also requires a short-lived regional weather pattern that can cause small-scale wind structures that support local fire spread. And it requires ignition at the right time and place. We often think of fires as something that happens as you turn the temperature dial up and down, but that's not true. Although exceptional national fire years occur only during Hotter than average years, 75% of hot years aren't exceptional fire years. It's an asymmetric problem. These become disasters when these are close to communities. So many places are susceptible, but can AI make this distinction across multi-scale processes?
So maybe this is a conversation to be followed up in the breakout.
I just have a couple more. I'll go first.
Yeah, we 5 minutes. We're going to enforce so that we have time for the conversations.
Okay, can I finish this? Generalization is not only across locations, but we have different regimes. The most extreme wildfires are either wind-driven or plume-dominated fires, and these account for are driven by different mechanisms. So our models can perform well on average fires in between, but fail on the most extreme events. More data may not solve our problem.
Can you wrap up now?
Yes.
Thank you.
We don't have a clean benchmark model like many fields do, or an established reference model. In our field, we haven't determined the actual skill of our wildfire model. So their own uncertainty complicate the evaluation of our surrogates. So how can we evaluate AI when we don't know what model success means, can't diagnose failure, and there's a lot of tuning going underneath. So in summary, the events that matter most are least represented. They operate under different dynamics, and we don't possess a reliable benchmark for knowing whether it's learned those dynamics. So the convergence challenge isn't simply to build better AI, but build the scientific ecosystem from data to the cyberstructure that allows it to become trustworthy. So for discussion, I present these questions, which we can discuss in our group.
Thank you. And Budu is next. So if you wanna come up. Nope, wrong. Find the following, and I think this is best we can do for the presentation version of it. Huh? No?
On the side, I believe.
Oh, right. Yes, we could do this. Right.
Yeah, you can.
No.
No.
Yeah.
Good.
Good. Thank you.
All right. Because I have academic 5 minutes, I'm going to skip most of my slides. Just to make sure that we all understand that these three big components of emergency response or time critical mission support, the real time criticality comes in the response phase, which is in the middle. The way the real world operational scenarios work is that you have 296 hours before the response period turns into recovery. That means your chances of saving a human lives is almost zero. So what the community tries to do is to produce data and answers, analytical products within that 96 hours to make sure that that data gets out to the response community to go and save lives and do this response. So quickly, we produce analytical things which has large uncertainty, and over time it gets refined. But the whole objective here, or the opportunity, is can we use AI, high performance computing, and novel data sets to crunch this towards 96 hours towards the left. The opportunity for digital twin is not creating just a digital model, but what we have been playing around with at Oak Ridge is the concept of digital twinning. That means how fast can you refresh your digital model with new data? And there are many ways people can do it, starting from observational and measurement, telemetering data into an environment, all the way to forecasting simulations using HPC. So I will give you from our experience of working, or at least my experience of working in this area for close to 30 years, what are some of the key things that people look for when it goes? One is damage assessments. Damage from tornadoes, floods, hurricanes, and even geopolitical conflicts, right? So you are trying to get buildings and the structures using some kind of visual model or AI models to generate. The other thing that the community has started doing, because to create 3D models to get a volumetric estimate of debris and destruction. And there are new techniques in HPC-based techniques on using stereoscopic image pairs and creating 3D point clouds instead of getting direct remote sensing data, for example, LiDAR or sonar. This is probably the coolest example that I have, which is training AI model on large HPC and then deploying it on the edge. This is a capability that is now fielded with FEMA and Department of Energy's ESF-12 functionalities, where the drones go out and they have one model installed on that NVIDIA chip, and it essentially looks for electric utility poles right after a storm, and it provides an assessment, dynamic assessment of whether the utility pole is standing up, it's destroyed, or it's undecided. Because the crew gets staged while they are waiting to get into the disaster area. And that data is in real time sent back into the command center using satellite links. I'm going to skip this one because this is more about metadata management. So the questions for the audience to think about is, where do we bring innovations for both in digital twin and then this new concept of Internet of Space that is coordinating from drones to satellites of a synchronized tasking. Okay.
Okay. And definitely not least,
Okay, I will try to stay in my 5 minutes here. So the contrast or the tension I want to think about here is scalable models that rely on data versus models that are designed with physics, with some science or otherwise constraints associated with it. So I think it's interesting for us to think about some of the wins that we're seeing in AI for science nowadays. And the one in my world that you often hear about are things like AlphaFold, protein structure prediction. One of my favorites is actually a little bit different. It's weather forecasting. A couple of years ago, Google released a completely AI model. And what it does is medium range weather forecasting. So, and their model that is trained on 40 years of data actually outperforms the European Center for Midwest for medium range weather forecasting's typical ensemble system for forecasting, and it goes faster, right? So this is an example we see of a machine learning approach beating a pretty incumbent physics heavy operational workflow. Another example that I'm seeing in my world is this idea of interatomic potentials for material science. And here, this is kind of, these three figures are a little bit historical, right? So the one on the left is the first learned model. So the thing we're trying to learn here is the inputs are, where do you put the atoms and what are they? And the outputs are, what forces do they exert on each other, so that we can run dynamical simulations of how they move. The first is kind of the earliest attempt to do this. The one in the middle, so no physics constraints, just kind of like learning from some raw data. The second one in the middle is putting symmetry in there, putting physics, so that if I take the same molecule and I flip it upside down, my machine learning model knows it's the same thing, just flipped upside down, and it predicts the same things about it, right? So it's an equivariant model. And then the third one just came out a couple of months ago. This is somebody who said, you know what, forget the physics. I'm going to aim for a scale. I'm going to use a standard off-the-shelf Llama 2 transformer. I am going to train on Meta's data set that they provided for molecules and just go for scale. Don't worry about physics at all. And she showed that in a way that's, to me, a little bit discomforting, to be honest. You can learn things that look like physical rules, right? Like this plot is how forces decay as the distance between atoms drops, right? Very interesting. So I think a lot of those successes have certain things in common. They are in data-rich regimes. They have learnable targets, right? We have clear inputs and clear outputs that we're trying to learn, and our accuracy requirements compared to some things that I often think about in condensed matter physics or we've heard about with respect to fires and other things are, I would say, moderate compared to some use cases. And I showed this slide earlier. What do we do when the structure of our problem is different from this? Right? What do we do, for example, in materials where we are scarce in data? We care about causality, we care about interpretability, and we have some guardrails, right? Things like symmetry and so on. Being able to find this guy, right, where we have 0 examples is kind of tricky without rethinking the structure of how we solve these problems. So I guess my idea here is that the structure of the problem that you're solving matters. A lot of the successes we've seen in AI ML were developed for problems that have a certain structure. We're trying to apply them to problems that have a different structure here. And so we want to think about how do we bring those successes to different domain areas. And so that is the topic. I think my discussion session is going to be shared together. Yes, we will be working together on this one.
All right, that's the Blitz overview. And now the breakout time. Now it's time for you to talk. So we have three breakout rooms from these 5 topics. First one is causal and generalizable Earth AI, room 206AB. Out, right. Group B is time critical and disaster support. Out, right to and continue to 2013 AB, and the group C, Earth system dynamics stays here. Here's the QR code for the notes, and there are tabs there for each one of the 3 breakout rooms. So you have until 2:30. 2:30, come back here. 45 minutes, ready, set, go. No?
Yeah.
No, I know.
We need to take Aleph goes and Iman goes to group.
Oh, yeah, sorry. Okay.
Yeah.
Right. So Aleph and Imam are in group A. Co-leaders, group B is Budo, and the group C, Janice and Molly. Okay, got it? Okay, now ready, set, go. All right. 45 minutes, come back with solutions. No. This
You all are the girls. Yeah. Oh. Yeah, already. I'm very. The left side of the cell is always
I just finished. This is for most of it. Yeah. So if we have on a screen, I just started. I don't know. Slides.
No, I totally.
Okay.
Lots of discussion. We've already heard all this. They just shuffle them again. Just point out. Alright.
Okay, I'll do this. And I don't hear that. So no. This way it is. Over the whole. He doesn't do it by. I'll have all my requirements. So they get. I like. I am so it was either. Also the street. But such able to. So that is one of the things. It was. The other, the other. I did, and they used to run cancer. Just moving the course. That's matter. So.
Yeah. The problem is this bird is. Yeah, and the problem is like, but it's also there. It's very fun. Yeah. And kind of a part of it. But we feel it's still trying to provide a process that. Yes, but very close and popular. It influenced with memory and things, and it would also. I just don't think like that. Oh, you did my reaction. My friends they need something. Why actually? Some of the details were like this work. They really which are as in. I've been doing that. So they started grading. And figured it out. Yeah. So you really have section. So there's nothing like it'd be fine. Well, I just need to stop. So like that. So if you ever offers they did, but so 3 hours of their classes. So that's the guy for me. But I didn't know something like that. And I they typically leave on her in their course. So hard to see right. So I'm like, I don't know if it's so I understood and then it's with someone speak. This I was just not so yeah, I think that but so that the process was so it was like a fun. That was 6 months. After that. Yeah. It was I've never mentioned that. It is weird. I was a little sad to see that it didn't do that.
Not just the applications, but so which is like ESP2. So then, yeah, which is like all the in color. They did it already. They just did it like what's so that's not the song. But this my mom's body. That's not 70. I did like that. It was a full house. It was like as I said, my only and then we put so the last yesterday final presentation, the final paper, so there's only 6 total signed in the last 5 the last I know. As a year of person, it's either he's someone to go down to constitution. I do not complicate. I got that. So I just like what I do, just say something. Yes, manager feels something. Maybe she saw it and that's why I don't see it. Yes, I don't see it. That he saw something that's beyond the clearly said that it was okay. He said, I trust you. So if you want yeah, usually do so. Oh, I see. Oh, really? We just actually are. So, yeah, like I gotta see. So, like my GPA. Yeah, if you get PM. I don't say you wish that anything out of it. They don't ever look at it. It works. Yeah, I just said, something about this. The worst grade I would say. Challenging, so it's not sort of a change. Not like it's just I just say. There are not house that their job. I think you get to use it. Feeling close that they will have. Like, that's how it is. With the. Like, put in housing. It's almost big of 4 bucks for the job. These same things. So try. Just physically, as I said, I need to. I need to. I know that you got to hear, but yeah, so I guess and I'll I guess but somehow very do something about it. He's not gonna take it easy. Yeah, exactly. As you did say, like the MCP said, what not. Yeah, that's people are so hard. He doesn't want to keep him. He has to open it up. Just try. So that I play. It should be a pretty addition. Yeah, I didn't say I couldn't see any of my question on anything. Yeah, I'm too excited to think. I am gonna tear for students. I have a kid, I have some you it was I just remember it. I was always active student when they made like the kid, they made and I great for that just like so like yeah, the diet. She didn't understand. So I was already like used to being oh not like not physical, not work. Physics I use my interest in, so I guess I don't do that. Yeah, I made it this far. I did like I did it. You know, I just feel like very much. Further, like the I think they graduated, I graduated class just physics. They graduated a lot of things from friends. Yeah. That's I was the size of the first year piece over and yeah, it's like physics. Then they've got a lot of people. Care for those things, which was nice. It made the original a lot easier. It's like some of those documents has to do with, and I've already just put these the push from. Because a lot of people where it's a very different cultural shirt and like you know, I don't know what there's a lot of losing out on very many, only. The other talks are, they're really persuasive. It's like, so, I oh, that's what I need. Oh. Already have the. Awesome.
Well,
yeah.
Well, what are you talking about? Yeah. What is the best way to say? One year since for the next year, I don't think
Actually use it. But I think it's San Diego. That's good. I am. I was going to like you had to and then spoke it back to my reasons here. So it wasn't until it had like when I gave them the well, and really lost that's really good. Yeah, that's great. But so I thought when I thought I was oh I would say no. And then I started like oh no, I didn't the word. I'm flustered now, but I'm not here. And we go over the other part, I started around, I'm like,
I know that is for a while. And so you have. And some things people say designs. Nice little, you know. Turbo, right? It's always been there. Especially those things.
I hope we're not doing that. One of my things was to.
That in every day. Oh, okay, well, I'll say that.
I see that in back to science.
Yeah, for all years.
I always like. It's very. Yeah, now there is. So all the things, 1, 2, 3, and that's what the big book title. And I kind of think with like
It's like a lot of AR and because it's still restricted. But is it also?
yeah, you're with them. Yeah.
And while you're like that, some kids there's a very sense. Really has something.
Celebrate festival outside weapon basketball.
Yeah.
Both work at my especially the maintaining the leader. So she said, oh, I need the as well as working on the staff. Well, we try to switch from tank to that's great. But she said, oh, I'm busy with things and she we go back to and that's fasting.
Yeah, and that's then it's like the dropper. I feel really funny. Yeah, that's so there are those. Oh, yeah. Excellent experience. It's not no hard. Yeah, and it's definitely difficult. I live on the coast. So her campaign is now like 2 hours. Oh, now I
my main part, we know it's based on budget. Yeah. The HR.
There are always and you feel it this is right. It is nothing.
I'm going makes you like I was my
actually it's not everything. We're supposed to have it
it's like but I like to study it last but I don't like the board.
People are like, oh, this Windows crack or something. But then like every day you know, it's like 60 feet.
I'm always also you like those scale things. You so but you it's totally the British yeah things like rockets. Then you have the rocket. I've done rockets pages of the rockets and the active ones. So like it's kind of but I actually just is especially since like in those bombs that so I just wrote two different pieces of it was a good idea. So not design state right now doing something right now in grade find general anomaly or if it's the trigger windows I think she always puts that what I like to do is try to stay just and that might just be doing and I'm already like one of the that's like so now once we get right I never did it. Sorry. It's on each of the would have to be for this fact for it's like yeah. It's right outside of the yeah. I think that's I've done the but I would either say now. I haven't said that, but there's so I will get to the I would have all the saucers. All the company for the connected with this red. I know what it's got better than it's 5 cents. It's actually really soft. So yeah, so it's like the one that plastic like damn much. No. I don't know. I was just one of my team was talking about because they said, oh, we did about 350 or blah blah years old. People always need not really. Yeah. It's just like the first word. It's just like so they have to go with the science. I actually make it stand out. Just kind of you're not that's what no, we don't. I'm raised in the so it's all right then. South one, some of the first one, but seeing the progress of the management of all of us. Yeah. That's part of it. Yeah, exactly. There's all more. Because it is something. Yes, it's supposed to find that. Yeah. I agree. It was and she's so big on the co-brother of the heat. I don't know what it was saying. Yeah. Yeah, so it was on the website. It's really people like it just goes like I give I don't know. They tried to call it function. I want something. So that's the only one that's all this. So HDR is back ready to work. You need to feel possible. Yeah. There's so many things that like I hear a lot of right. Say they're not the ones that are being. And it's all done with like also on the other you can go good medicine. Awesome. This happens. I was looking at it, and the first one was years. Yeah, that's another like. That's probably the cell largest. That's why I think. But I think it's. Yeah. Yeah. Now, yes, I think they is going to like the entry of people to like did it with an album. You could just getting part of the I have a yeah, I made it close to second. I think that I go up and then I got that OPT. I have for 3 years, 1 year, and then it takes good. Then after that, I did have H1. Yeah, the H1B we have figured out my it's the block. Sorry, without the H4 so that was have to and then also what I know is my 5 students from them. They can also calculate by maybe
So this is all projects. It's like everyone I've come across, wait, are we trying to do this really census? So if the president thing happens and he's a little bit off, we can educate strategy that are non. We may already know. So every red dot is a
Yeah. So I know if you go to the meetings, I don't think they'll just take out long nights and I'll make sure you have the actual but also yes, with that on the things before or yeah, so if you are online ones, wait for me. So I've definitely or was that other not music for trying to one version B. He was no fee, and then only through of course they was. Now this one is blocked by the law, another including for students as a fee. I think there's that when they're rich for as you even see. And that's what he was saying, where students are rich that's I mean, as lessons, well, there were eight from travel. You know, anything else? My brother does me speaking on that. Every month, gives a it's sorted on. Oh, that's what I'm trying to say is. So if you would, and you say it, or you can just say it. So. You have what, 6 Yeah, I know. 100%. I think they're thinking. They are. My thing is, oh, let me through that you're practicing that confidence aspect. Or and also just
and that's right.
It's a good privilege. But I think the paper worker. After that, I go myself. You can scroll enough to be able to just go say for even that's one of trying to get no, it's 230 out of the 139. So there's all. And we just the realization that they almost make shows. Yeah, we just have enough. But always look back. And it can take us.
We're smiling, but I know how much pain that would be. Yeah.
Okay. Everybody had lively and stimulating discussions. I know I've picked in on all of them. So this is, I can't wait to hear what the hot takes of your discussions were. So everybody more or less is back, right? Well, you're getting back. So the three reporters. Hi. Okay, so people are kind of back and forth, but mostly back. Mostly back. Group A, are you here and is your reporter here? Yes, okay. Group B, are you here and is your reporter here?
Yeah, group is over there.
Yes. Group C, are you here and is your reporter here? Group C? Group C? Is your reporter here? Yes? Okay, great. Oh, you don't need to come up. Or yeah, you can. Actually, let's make it, everybody's voice is strong. So let's start. Let's start with group A. So, causal and generalizable Earth AI. Coming up, tell us your hot takes. Couple of the summary that we all should give us the FOMO version of the fear of missing out, of what did we miss out on?
Yeah, so we talked about a lot of things actually. The fundamental of causal AI and causal discovery, causal inference, and also what if situations, like what if something didn't actually happen, but we want to know what would happen if the situation was different. So like answering those counterfactual questions, what if questions. And then we also talk about how do we actually define, like, okay, what is the significance of causality, right? So how do you decide that it was actually a causal influence, right? And also, what do you do if we don't have those particular data that we are interested in? For example, we talked about missing variables that we didn't consider, the confounding variables, right? So you know some of the features that are available to you, but you missed out other features which are probably like hidden, and you cannot measure them, but you are assuming causality on the variables that you have, but you ignore the variables that you don't have. So those are I think, the main takes that I would say. But it was a nice discussion. Everyone is involved in generalizable and causal AI. So thank you, everyone.
Yay. All right. Time critical and disaster support. Coming up. Coming up. Coming up.
So in our discussion, we really discussed a lot, lots about the research that highly related to the timeless problems. So we can say from here we discussed yeah, let me count. Yes, we discussed the 22 questions. So let me firstly, maybe I can show you a case from the first one. Like, is knowing where the flood is where or what a response actual needs, and how should the AI model uncertainty be used in these types of tasks? What lead time and confidence level should the triggers a public flood warning? Yeah, so we discussed a lot here, and we also know a lot that, especially for me, I know for my research about the flooding peak prediction, I should care much about the public and how what types of information they want and what's the time or what's the lead time they want. So it's really helpful. Yeah, we also discussed others like what types of information shall we consider when we use that, and when we deploy our model to a certain types of application field, how can we make this decision much faster, like for the edge deployment. So edge computing, these types of things is really helpful. Yeah, I think there's a lot. Maybe if you are interested about that, you can search our document. Yeah, thank you. Yeah.
I like from my peeking in on that group, I learned that the main difference between a catastrophic event such as flood, fire, drought, or hurricane and the disaster is that humans are involved. So the question is, how much can we learn from catastrophic events before they become disasters? Okay, last one, Earth systems dynamics.
Hello, everyone. So our group focused more on, I think the direction of our conversation went more towards causality and correlations in Earth systems. And the point was to understand if AI models can distinguish this between causality and correlations, and then how can we definitely trust them or find them reliable. Our conversation really dwelt on distinguishing, between physical models. One of our folks on the team was leveraging a lot of physics models in understanding wildfire spread and trying to see how AI models can be, translated to be helpful in physics models or advancing physics models. So we primarily discussed around foundation models, surrogate models, and also then trying to see if digital twins could be leveraged in this case. Of course, in our expertise, there are so many limitations, so many factors to account for. There's a lot of uncertainty. Also trying to see if human intervention can be leveraged in this case and how it can be helpful if it has a role. Then in understanding if we can trust or find them reliable is what types of metrics can we identify that can then be leveraged to measure reliability or trustworthiness of our AI models. Then other questions that we looked at was understanding connections between different Earth systems. Of course, concepts about the dynamism that occurs in the Earth systems has to be sort of broken down, and then how can we leverage technologies like digital twins to make or capture these connections? Additionally, given the complexities, can we look at workflows? Given a lot of uncertainty, can we model pipelines taking into different uncertainty variables and then bringing it all together into a workflow to model more complex relationships? For seeing if we can help AI models make more reliable predictions is looking at how we can train them more, making them more generalizable. And then if we have cases of sparse data, then we can leverage stepping stones from unsupervised learning into supervised learning. And then lastly, if an AI model can detect inaccurate causal relationships, basically, in an event of a rare event occurring, so how can it diagnose itself? Then that comes back again to how can we model uncertainty, having a human in the loop to sort of stop the process when we have such cases, and then try to account for self-correctness in the model. Yeah. So, thank you.
Oh, it's we have mine under here. Yes.
Well, thank you all. This is fantastic discussions, and I am impressed also. Like, to me, what jumps out is how much connection there is across all of this, cross-cutting themes of uncertainty, causality, digital twin dynamical systems, quick updates, define quick for different systems. So to me, that means that looking into the future, we can collaborate, we can continue to collaborate, right? There is a lot more left to be done that truly has connections across different themes, different institutes, different projects. So thank you. We're going into the break right now, right? Until 3? Huh? 3:15.
Let's do 3:15.
Until 3:50?
15.
Until 3:15. 3:15. There is a break. So there's popcorn. And before I lose my microphone, I will give it away. Right. Putting the hat of my cultural attaché for the city of Chicago. If you're looking for something to do today, you can still go to Blues if you didn't go. So Buddy Guys is there 7 days a week. There's a different show today. but if you're more into jazz, Jazz Showcase has a fantastic show today. So the Chicago Jazz Showcase, and you can actually decide even going one or the other because they're close. So they have one of the best, like truly the best female jazz singers performing for the next 3 days. She's Chicago native, Chicago West Side. Come on, this will eventually load, right? Okay, never mind. We can do the now playing. Nope. Still no. D. Alexander, there we go. So D. Alexander is a gem, is a Chicago jazz legend. Highly recommend. There is the 8 o'clock show and the 10 o'clock show. General admission is $25. Enjoy.
Want to say something about that? Yeah, and you also just got an email message about this. We had been remiss in letting everyone know that there is actually a brief 6 to 7 p.m. reception tonight at the Marriott. And it's for everyone. Most of you are at the Marriott. Some of us are lucky enough to be over here at the Hampton, which is also a lovely place. But the Marriott, 6 to 7 p.m. in their bistro room. When you get there, you don't have to be there. Anyone can go from our group. They'll give you free 2 drink tickets, and there's cheese and crackers and fruit. So that's from 6 p.m. to 7 p.m. only. You can do that and then still have plenty of time to get to jazz and anything else that you want to do after that. So, and if you have friends who are not in the room right now, have them come by the Marriott. They have plenty of space there.
Terry.
Yeah. It's the fastest growing.
There's also sensibility else. Yes. You have to look around. So that probably my favorite. I was gonna move on. I don't use my voice. I don't know. I just don't think trying to think about what so I guess it in my case, I'm really close to what are you? Yeah. Kind of busy concept. Like you need to think about it. Yeah. That's kind of pretty well. Yeah. Oh,
Give me 1 second.
See that numbers not changed, yeah, I understand this thing. It's true, mine's been charged on the charts.
Yes. Yours just screen gauge data.
People much more clear and most of the medical facility and support is on that. But in particular, we have this investigation. And also, people I mean, we both come about. So I will say but do something that we should go from to that. You can that's right. The other thing that in the first so I submit all my scholars for very result in so you can say now I thought that's actually saying we have my and so I like that's what so I told them yes and over I had and people see yeah the parties were 17 from the people disappeared. So
It's an interesting. Are you so the one that I know has successful
It's just
That's fine. The investigation of people. That way, it's like so high. Like so, and I felt the owner of this data have these change. So that's why I talk about that again. At this use as I think animation context. But for you, so like it's really not going to go. Look back on top of people when I have to be 3,000 times. So yeah, so first, I treat the model. So that's a very good. Treat the models that I'm pretty sure they're pretty pictures of you. They are running data. You know, so let me do the testing of this policy every year where so let me do between all those two lines in a certain area. So that's what I've decided the high uncertainty. That's what means I use with much and get across here. So really, I think they're good for that. I don't need that. Yeah, and all the because we have to studies. That's a big one. I had 7 years ago. Producer sugar and test and yard. So people are taking 13 minutes. Right, so all those predictable. So that's what I want to say. That what's unpredictable? What is that? I tell you, I know those that's actually like a social thing. Actually, good. Yeah. So I'll like students start out to they're relatively in the sense of it's hard to explain the factor. So this is what you say about the situation would change because the next Harvard is just
so what's it to you?
So it was the tactical and the lousy and some yeah, so because just around that we completely break up the podcast. Zero all day. So it focus but that's all the weird song let me speak. So that's nice. Like a good yeah, brother, it's
So that's a sensor. Yeah, you see. The same sensor that's on the phones. That was where the one. You go over water and
I also want to be so that's I want also ask And it's just the five distance. Bunch of things. So. You ask them for the essence of that science. Also, I mean, my carbon has no. I think my carbon airphones.
I'm running it's the.
Yeah.
That's a good. That's
But yeah, now I mean, there's that. There's
The model is very similar the example. So no,
they're quite. Every single
you want to find one paragraph.
Last night I was having down
I found that there's something.
and
I was.
that actually has a big reaction. And they were the it wouldn't take care of, I not get it was labeled, it's like, yeah, we're not gonna not get on this way. Yeah, so they just see the individuals somewhere else and I don't care.
So people look at that. So.
They don't hold the they climb up and say, well, but I'm kind of, you know. Still get it. I think they get like 2 hours of this transfer. Just because I was. So then I have.
So it's a school that would be water. Suck that out.
It's right there. Like it can be down. And they're
so for a house.
Very
all of the
80 miles. And I was at the airport and I'm that's why I could go to every other airline.
That's like the big cost taxes. Just get to there. It's pretty down time. It's always like how it's long. Right? Yeah. Because no, it's not. Yeah. Then.
Yeah, I think it's so. I'll think about it.
I think that's everybody else.
I was just looking at, see that Google got this.
All four are opened up and you have the document and you have, yes.
And the tabs for ABC?
Yes, thank you. So then there is this document that you had.
That's
So
just a,
just a summary, right?
just a, what's happening in this session.
Okay, that is an error. I don't know what
Then you
that is. So let's see which one had that error. Then is it too big or not? Oh, that's good. So wildlife trade. Rethinking. Okay, so we have four.
So we just go in whichever one.
Yeah, it's fine. So you whichever one we want. So.
It's not just, I have no there.
So my API, yeah.
The five fractures, the future. So I think we should just get together. And I don't think for files first. The panel. It's gonna be out.
So they go.
All right, let's get started with, I think this is our last breakout, if I'm not wrong after this, right? So let's get some energy for the last breakout. And I think this is, I'm going to be, selfish and say this is probably the most important topic, really, because you cannot do your work if you don't have the data infrastructure and data or the infrastructure needed to run it, right? So we all struggle with data. I think every HDR institute started with the grappling of where the data is and how to get it ready. So this session is really focusing on what makes data genuinely AI ready. And I like the word genuinely because it packs a lot. You see all these data sets that you can use our data, but it's not ready. And who is responsible for making it happen? Is it the person who collects the data? Is it the organization that puts it out? Is it us who actually end up using it? So similar to the other breakout sessions, you will have 4 5-minute presentations, and then each of these authors have been voluntold to lead the breakout sessions after, and they'll have their own leading questions. So with that, I'm going to get started with the presentations, and we'll go in the order of the slides, just like in the previous one. So let's go with the first one. And I'll come up. Oh, I'm sorry, I probably shared it. I'll come up with this one. Oh.
Thank you. Hello, everyone. My name is Hashir. I'm a postdoc, and my position is very simple. Most of my comments and concerns will be from the opinion of a geographer who is diving into the ocean of AI. I work with illicit wildlife trade, which is a very well-organized and a connected network. But if we represent it with fragmented events, it will be not easy to understand. We'll lose a lot of information. So I argue that even if we have that scrambled information, if we connect it through these knowledge graphs, we might have some better information. So we do have data, but it's like spread around different areas where we cannot sometimes access it because it's confidential data. So let's say that we have data where we know that 50 tons of shark has been seized, shark fins, but we don't know where is it originated, where is it transit, but we know that where is it going. So these are the kind of information that we lose if we try to represent the data. So my team does this. We collect as much as possible data from open source. We curate it, and then we give it to an LLM to make it standardized. And then we manually validate it, whether the data we are getting, is it according to what we want. And then eventually we have multi-relational graph that tells us the complete supply chain, where the data originated, where the event originated, where is it going, and the transit through these spaces. But this leads us to the question is that, it's actually my opinion. So in my opinion, data is not genuinely ready if a model just can use it, utilize it, change it. The data should be ready if it goes through this schema. Someone has to follow a shared schema, a validation, a provenance, and relations of geography. But these processes are distributed among different set of researchers or organizers. Someone know the context, someone know how to validate it, someone knows the geography behind it. But since this is shared, how do we do that? Which leads to my 2 questions. At what point we say that it's ready to hand it over to an AI so that we don't have to do all this manual work? And how do we keep this uncertainty visual at each stage so we know that, where we have to tackle the uncertainty? Thank you.
All right. Next is Eric.
All right, thanks. My name is Eric Sokol. I'm a quantitative ecologist at the National. Oh, I'll hide the bar. All right. So I'm a quantitative ecologist at the National Ecological Observatory Network, and we are a data provider. So we provide continental scale ecological data to researchers and educators, free for anyone to use. And today I'm going to be talking about the FAIR for AI Bio project. And our objective is to understand AI-ready data infrastructure for ecology and biodiversity. This is in partnership with folks from the Imagomics Institute and co-authors listed on the slide here. Let's see, there we go. Okay, and so when we're talking about AI-ready infrastructure, the first question we need to ask is what do we mean by AI-ready? And we've been thinking about it in this project as a continuum from FAIR data principles, so findable, accessible, interoperable, reusable. We've heard about FAIR principles already today quite a bit. In a continuum from FAIR to AI ready. And the last talk actually did a really good job describing this difference, right? So FAIR data, they're machine readable, have rich metadata, but aren't necessarily prepared for particular use cases. Or AI-ready use cases, whereas AI-ready data are ready to be included in AI infrastructure at scale. So a lot of work goes into making data AI-ready, but AI-ready for one use case is not necessarily AI-ready at scale for another use case. As a data provider at NEON, the National Ecological Observatory, we are not going to be able to prepare our data for every AI use case that's out there for ecological and environmental data, but we can do better than traditional FAIR. And so we're interested in what this AI FAIR level is. And so we'll talk a little bit about sort of the discussion we've had within our group to sort of narrow down what we mean by AI FAIR. But basically data that are machine FAIR, but plus. With minimal human intervention, you can move it over to pipelines at scale. And so this project involves different data providers. So us at NEON, the Long-Term Ecological Research Network, the Environmental Data Initiative, GBIF, Smithsonian, other data aggregators and data providers, folks that are using AI infrastructure to ask scientific questions in this space, so the domain experts, and then also folks developing AI-enabled workflows and tools. And as we've been discussing sort of what a distributed ecosystem of AI-ready data look like in our domain, the problem that the unidirectionality problem has arisen, which we've realized that data and value flow one way typically from the providers to those consuming the data. And really for this ecosystem to be sustainable, we need to think about how data and value can flow in multiple directions and benefit could come back to the communities that create and provide the data. So we've simplified that diagram down to thinking about it in terms of a triangle where we have the research applications that are question-driven, the data and data providers, and then the models or the AI ML tools. And thinking about with these vertices, all the edges between them, all these relationships should be bidirectional. We want to think about round tripping of value back to the origin. So there should be benefit flowing in multiple directions amongst each of these vertices. And this informs how we think about what the infrastructure is that we need to build to make our data AI FAIR. And so just as a quick example, we can think about this neon beetle imaging project. So folks from Imagomics and some researchers, along with the help of the biorepository at NEON, imaged over 60,000 beetles, have this AI-enabled workflow. They extract all kinds of ecological value, and making links back to the data origin at NEON is really valuable to the community and is only possible if we can get the infrastructure right. So a step toward doing this is we've been developing an AI FAIR checklist so that we can provide a framework to enable thinking about this question data model triangle, its connections, and how we can enable round tripping. And so mapping specific AI FAIR criteria onto different relationships within sort of the ecosystem we're thinking about, we've focused on structural, scientific, provenance, and governance requirements. And so basically, we have a checklist with items that map to these. And we've started creating a tool where you can essentially point your agent at a data set, the checklist, evaluate it. We have basically some skills that you can use. And so here I'm pointing it at a Neon data set. And then we end up getting a summary of strengths and gaps in the data set for its AI fairness. It returns recommendations for the specific items. And then on the right here is a distribution of, I've run all the Neon data sets through it and a bunch of other data sets from our project working group to kind of give us some context where we sit in terms of how we're scoring things in terms of AI fair. Interesting, CARE compliance. So we heard about CARE earlier today. That's the one where the distribution's farther to the left, so not scoring as well. So this is kind of giving us some ideas of where we need to go in terms of developing ideas for AI fair compliance. And so with that, I have some discussion questions. Basically, what do you all view as necessary AI fair criteria? How do we define and enable bidirectional flow of value? And what are important aspects of provenance and governance that are necessary for round tripping? These are kind of the issues that are least well developed so far in our group. Thank you.
Next. I should hide this now. Okay.
Hi, good afternoon, everyone. I'm Chaya Kulkarni, and I'm here to present my position on rethinking AI readiness for multi-source geoscience data workflows. So many of us work in the geospatial AI space, and we rely on amalgamating data from different sources. So we pull in data from satellites, reanalysis data, sensor recordings, and other such data. And my position is that if we evaluate just a single individual data source, that is not enough. We need to particularly look at the workflow that is used in order to integrate these data sets together. So when I talk about AI readiness, what exactly do I mean? So how do we define AI readiness? Okay. So AI readiness, traditionally, it means data that is reliable, it is machine readable, and also interpretable. And in geospatial AI particularly, we need to also understand, pay attention to the location, the temporal aggregation, the scale, and also how exactly we are creating that data, what kind of transformations we are applying over it, and what kind of uncertainty does it carry with it. So together, it helps us in determining whether we can safely integrate all these data sets together without losing the original intended meaning. So let us understand this by looking at a very simple example. So we have the same location data and also the same temporal aggregation is used here. We are pulling in one data from NASA Power, so it gives us temporal estimates for the gridded region on the left, as you can see. And then we have another data, which is the NOAA GHC and daily, and that gives us temperature data at the local scale. Okay, so you can see that even if these two data sets are there, firstly, you might question, why do we need these two different data sets? The purposes can be different. It can be maybe to do a bias assessment or a comparison or a validation study. That's where we can use these two different data sets together. So while we are amalgamating them, we need to pay attention to the variable definition, the unit, time aggregation, and the area represented. So we are well aware of that. But what about the workflow readiness? So when we are looking at the workflow readiness, we need to look at the cross-source alignment. And for understanding the cross-source alignment, we need to look at the transformations, what kind of interpolation we are doing, what kind of validation we are applying, and also, again, are we inadvertently introducing any kind of errors, and are we acknowledging that or not? So that also leads us to the next question, that is the shared responsibility. I'm sorry, so before looking at the shared responsibility, one more thing that I do want to address is that multi-source readiness, it can be evaluated along 4 dimensions. And these 4 dimensions that I'm proposing, These are not novel, but it can be considered as a starting point in understanding the workflow. So the first one is harmonization, which will help us in looking at the compatibility of the data. The metadata and provenance will help in understanding about the data and the changes that we are applying over it. And the uncertainty will address any kind of limitations or errors that we are introducing. And finally, reproducibility addresses what kind of what kind of data and code can one use in order to recreate that integrated data set. So the next part that I would like to address is the shared responsibility towards AI readiness. So as you can see, I have 4 entities listed here, and all of these 4 entities play a part in the AI readiness shared responsibility. So the data producers are the one who make the data available, and the repositories preserve and in a way make that data usable. And then we have researchers who use that data to create the integrated data set. And authors and reviewers is interesting because it is in a way the responsibility of the authors to make that kind of integrated data evidence, justify that, and the reviewers also play a role in not just accepting the model performance alone, but also look at the workflow that went into creating that AI. So finally, I would like to conclude by saying that my position is that our responsibility towards AI readiness does not just end at looking at the AI readiness metrics only at the single source level, but also at the integrated workflow. And these are the 2 questions that I am particularly interested in discussing. And those are: what minimum evidence should be required? And also, what kind of responsibility in presenting this evidence belongs to the providers, and what belongs with the integrators? Thank you.
Great. I think last but not the least is you have a, let me just do this first. Here.
Hello. Hello, everyone. I'm Jawad, graduate student at Oregon State University. The position paper is based on a work that has been funded by Aegis. It's an aviation company. So the position paper, the title is The Legibility as Infrastructure. It's basically a case study for a tool that was developed, a RAG tool, for the grant funding in the Texas region. So basically, the question it asked is what makes actually the data genuinely AI ready, and who is actually responsible for making the data AI ready. So generally, we can see the public flood data is basically, in many cases, fair and machine findable, but it is illegible to the people who are actually using it. So legibility is important missing dimension for the data being AI ready. So I will just give you a brief before diving into the actual case study. So the Texas Water Development Board divides Texas into 15 different regions who are responsible for overseeing the different flood projects. And each of the region has allotted projects across 3 different criteria: the FME, FMS, and FMP, which are the flood management evaluation, projects, and strategies. So there were above like 4,500 projects, and each of the region has documented these projects across like each document of multiple thousands of pages. So which summed up to be almost like more than 50,000 pages of document, which includes different hydraulic results, different numeric results, and it's based on the different data domains, which is hosted on the Texas Water Development Board. So some of those hubs are like documenting the critical facilities, flood infrastructure, flood risks. And so these includes different shape files, numeric data, and flood images. So basically, when filing for a project, the county needs to go through all these documents and determine which of the projects out of those 4,500 projects is actually eligible for the funding. And generally, those documents are very scattered, and many of the small counties don't have a very clear idea which project to take to the Water Development Board for the funding. So this is just like putting into numbers what's actually at stake. In the cycle of 26 to 27, the Water Development Board allotted more than $300 million for these projects, which comes up to be each entity is eligible for almost $20 million per project. But many of the counties don't have a very good idea which project to apply for. So generally, it's basically we developed a RAG pipeline for helping the counties to basically determine the important projects that can be presented to the Water Development Board for the funding. And in order to generate that RAG pipeline, we did like the general like chunking, retrieving, synthesizing, and kind of like determine which of the data to take into account and which of the data not to be taken into account. And so the counties have basically kind of like a pinpoint vision of which is the like important projects that can be presented to the Water Development Board. So this is one side of like building the RAG pipeline for developing the tool in getting a hold of the data. And this is basically actually like the results of the case study that was helpful for the counties. So this is one of the project that was like scored pretty low in the past 2 years, but a project of similar area was like funded by the Water Development Board. So what was actually missing from this project compared to the last 2 years? So what the tool found out, basically the critical infrastructures and many of like the defining factors were missing. So that's why this project was ranked so low by the Water Development Board as well. And for the county to bring this project into account to the Water Development Board, they needed to have like a clear documented proof and idea that this project is eligible for funding. And the fact is the county was allotted $20 million, but this project is actually kind of costing only like $4.5 to $5 million. But this is a very important project for the San Antonio region, which was completely not taken into account for the past 2 years. So after like bringing this account to the Water Development Board and also the county as well, they have like decided to fund this project going towards like the next year cycle. So like almost like before going into the questions, like the key point that we kind of like concluded that we have the data to build the models and kind of like scale the model as well. But what is missing is giving a clear direction for the users who are like going to like take the results from the tool or from the data. And this is the 4 questions that's basically I'm proposing from this position paper is data AI ready when a model can parse it, or when a non-expert can actually act on the data as well? Like basically there's like 2 sides when we are like developing a product based on the data. And what is the minimum standards the data set might need, like the different metadata, a structure, or like a query layer before the open data becomes AI ready? And who is going to own this eligibility layer? In this case, is it like the counties or the Water Development Boards, or the ones who are like developing the tool? So yeah, thanks for the platform. I'm open to discussion. Thanks.
I like that last question as well. Question 4, who owns the errors? That's actually more interesting too. All right, so with that, we're going to transition into breakouts similar to the other breakout sessions that you've had. The group A, B, and C is, like I said, group A is led by Chaya, focusing on readiness and usability. All of us know where the rooms are, right? Group B is led by Eric in 213 AB, which is focusing on fair and bidirectional data infrastructure. And Group C is led by Hashir and Jawad, focusing on knowledge graphs and event extraction and decision support. And how long do we have, Anand, for them to come back? It's 3:50-ish. When do you want? 45 minutes? Okay, so we'll say about 4:30 they have to come back. Oh, let's see. Oh, maybe. Did it work? Oh, here, let me just do that. All right. Takes us to? Is the QR not working? Oh, I think all the leads have access to this document in the folder. So you should be able to get that. I'll update the QR code again, just to be sure. All right, so we'll see you in about 45 minutes, around 4:30.
Yes.
It's just very bad.
Thank you.
You brought an IT guy. Is it already fixed? Okay, so.
Yeah, it's not working. You
No.
probably went to the.
What browser is this?
Or hide it.
I'll just- Actually, I thought we were using Chrome. What's the what's a good place to generate a QR code? Okay. Oops. Okay. This one? Yep. Is it this one?
Yeah.
Yeah, use the sharing.
Oh, just use the link? Yeah.
Let's go to share. Copy the link.
Why not just copy it? Sorry, I was so proud of being able to do this, but. Okay, try that.
Taking to that other one.
Oh. This one? Oh, it said it's not the final version, so let me.
No, go to that page. I think you have to download QR code or something. It probably didn't generate it at all.
Gotcha. So. Is it okay if I do it with this? Yeah, that's what I was worried about. Okay.
Yeah, I'll generate one.
Okay, cool. Yep.
Yeah, so we can have access to. Yes. Yeah, so if you go to this, and it's a reliable and something, so you guys. Very good. And sometimes, yeah, so this is probably not, that's what I'm saying, think that you want to. Is you don't, the one that you without say every time it goes in. So it's just that. There's no special. You're gonna be, yeah, you're such an annoying. I know.
So every time. What you do wrong? Oh, I'm sorry, there's a person who is in the different. Oh, this is what I am president. How much for everything you put there? We have to do there, so. How would it? Gradually. With the input, it's going to build. One of the positive building. Yeah, I saw a board. Here, I didn't expect to see you. She was my program officer and she was the sales. So, for a couple of sellers. Yeah. And so we tried to get in touch. So, another time, the wife was talking. And so this happens like, she said, you are you see now, as I computer. I know, see, I was telling her, these guys are Christmas choices. So, yeah, she was a guy to do it a lot. And I thought she still was, but she said, why you see a lot? Yeah. Yeah. Where is she? Yeah. 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 Oh, really? I saw what she did that is perfect. I saw the back of the wife, the disabled person, and it's a whole trial. Of course, yeah, it's changed. Says that mental here. Yeah. She has twice. Either one of us, I knew she was going to be the secretary of something.
where I get to talk, but.
I told you, yes, but thank you. Because, and he had a chance. Yes. So oh my God.
I like it there.
Yeah. So, but we may try and session. In the lab, we so it's really yeah.
You always look at the good ones, which are a lot of fun. It definitely said it was not fun. I tell you. It just needs to just. Because the little.
Yeah.
She came. I came out of the office 2 weeks ago. I know you work on the freight article. She says that no, nothing. I don't know what to do. Like I should have. Well, should with this other stuff with. A little while to figure out what to do. And she, she reminds me, I said, that national social plan. You know, I've been at that event for a long time. I'm really cheap. She got and he's very old. Said that I flat put over and she's built up. She's been over ever since.
So you see.
I think the key three is not problem. That's very small. So these are easy. Very much. Yeah. So maybe everything else. This is what it is. Yeah, I have a. Yeah. And I was like, where is it? And I looked for and here I am. Yeah. Very important. Yes. Good job. Yes. When I was in high school, I knew I didn't need to fit. I would be glad to get over it. At that time, yes. That's what I'm saying. There was one graduate. And there were only 5 substitutions. Then I did the night, so. The United most said, all over. Same, very well. So, and yeah. San Diego, Hawaii, and then so, so I wound up going. That was the way to go involved with the cultures. I was excited. The law of the case, so she said, what is excited? Every European being what's going on? And I just read about the history of it. No, well, I did well. I can't come down and go to the shower, whole shower. Say the game. What? I had all this, I had over it too. It's a long straw. And when I asked yes. Like that, beyond. South station, one of the spot on it. So I said, I want to hate, that's what you still try. And so I said, no investigation, no, and it actually found travel very specific. I just wrote the paper. Most people travel species. That was for about 50 years, generous responsible. basic research and atmospheric science. And some very big names in atmospheric science and advanced. Like these pretty terms about no, it was a track. Tom Malone, they're all the perfect. Or Jesus and car, search program, they go to track was that this is a slice. So what is this? Yeah, they were very clear about this. So they said, you know, when there's the big legal campus, so everybody, and we realized that the it's really not focused on music and about the same time we can same push and then started travel started there. It was a whole wall system of that sort of science and then by the time that he said the corporation decided on that sort of science. Some generation of some travel people very good some and that's how I found on I had an office job, but then when I walked there, that's how I felt like seems totally fine, no problem. There's no, that was great. It was long. I couldn't never even think about it, but it makes sense if you're hoping to solve it. I need to find all the that's didn't get some foods. Don't ever look up. Yeah. You take the look up, you get very don't take it. What's the next test? That's the only way you can do it. No idea how we did it. They've forgotten to want to do it. Trying to make it small. They don't have space of the ground. Also have a sort of concrete. Follow to the last company out of some problems. This kind of like competition going to the people successfully follow the people that have the system people that think about out of the city. The problem is here's something. But the problem is when it's a smaller model than the so that's such a big compact that takes the debate. But always good that so 8,000 and probably how we structure that up, the right account from that part is also part of the company. If you don't want to do the also different part of the account. That's when we get the account to the report on. I saw it. And the smaller doesn't be not that much on probably all the building model.
there's one. I think that's also there is another. Stuff, but it's not hearing that right. If I'm smart enough throughout the process, I'm supposed to be the content of it. Whether or not, they are all self on but wait for you to think about it. Spend months in I'm not often of it. But still, I mean, you follow helping all the time on the say that. Okay, that is that because when there's a scrapping data. What are those factors that we consider? What is the thing that algorithm can approach before we kind of we have to check where what else we have to script before building it. Moving on all the way here with confidence, do something. Or doing that action, I don't check those. That will handle it over. I think when they tell them give us data, but I mentioned the movement of the filter. It's not on the data side, the will be ready for the analysis. Before, it's not the current mark up as before you even thought it was not put on, do that. We're asking that you want to see action with the supply chain. So our idea of having writing because we think that this legal training for the work of a business, most of it is difficult. And we figure out that legal and they work at this much. Why reduces of get that product and all of this stuff. But if we can't understand the punishment, we will deal with constraint. I understand that it's part of in about that, the other things is upfront. I think there was a part of the about that. Without happening, I assume we should have clear these translations of what was both involved say well after tracks for the cases on or learn the adjective. But so I assume we should have at least idea of what people are Stephen. David Stephen. I think that should be part of the book with I saying most of them how they or for you to fill out those articles instead of not I think that's what they want to do and whatever the application relation. Right, that's what I mean, that's right. I think that's all of it. Already. And it's validation. Whether that was almost but see the problem is still have to do manual, but they have to be manually shut. I'm not sure that I'm at some point I get frustrated in how many times I do the skeptical idea in my head that they should all of them, they should all of them, but I don't want what my needs like those. Eventually, like how to share. I think I try to use that out of that factor. The video is that how do I divide it? Imagine, but it's not paying the topics not people broken. That's how it's not the key. You're trying to use the practically you're trying to from the transit. So one silver of example yes, that's the behavior, but that's the one in our observances, so we want to reach kind of bring I see but what I did is create calculated on something. People but the calendar is for how the larger component from that we have really confident that some will take not confident for income. We have to do it. Why do they this is why do this why do this be? Because we're trying to do power. But there are also discussions about bias, so using I that's that define others, define how in producing something tonight, in the world that then you evaluate the outcome. Things are just without but written that's all and story and how about all the ones that come take a while probably number the word looks at another confident thing sometimes look at our store about the I ended up I think that's probably also that's also kind of when it's talking about with yeah. You can, if you want to this, well, there's I know that goes down if we lose them, but there's a pretty confident that is not but how about the factor? They will and I think that's like probably bring out one element down the two factors for the time of the value. Well, what happens in that time that we go to is for things most probably was that that's also and I think probably is pretty good for the value probably better there's a such a part here you can have to leave the store on that will be the program. Or down to case of comfort, the with the pretty dry. One question you ask for data. Many cases. So, And see the trend. This how something that was helping out able fail when people power to call something because there's one thing about all and they stay within the yeah, I mean, that's also, but that's also the mathematical planning. There are differences from our planning to the planning. Basically, the state problem does it for prime conflict. That's what it for your things it still seems like a open the part for another. In those cases, it's not functioning to the people, it's not divided. Final performance of the format, how the person. I think there difference that might be a better way to but how to they don't even that's not need to know about the visual. The purpose of it. There is all those stuff things down to the fingers. Anything that is beyond the random, right, that's how you solve it. People put it on, but I would but right inside, maybe so right it's before but I mean, it's based on the opposite of planning, outside of profit. You know, those are stuff that country is possible. But the problem is, I really want to something, I need how I need the job. So that I can calculate the profit based on what I found. Even if it's true, but it's not that it's not the profit. Could be a hundred million dollars. I need to report. So that's also the thing. Talk about the fire or you have to pass down. That's the easy side of all the same possibilities. If I think that's the line. Right, like sitting all the not in front of so in something I feel in something outside about so it's like so basically we have about I'm using some of the action. So some of the people might sue as well as the space on similar moments all the Probably one of the most effective so but I can't say my phone for 2 hours, but it's anything that told me like I see that what's the song? I feel like it's fun to understand. People are talking about the pass it through time. If you did not like it, if you do it for all the time, it's very lots of this. It's a certain things to run it, but trusted by that rather than the legal. So we really work with these space. There's always essentially some size of this one, so I think how the people always actually. But we were specific days. If you were also previous. It should get two less than you can take on the fourth. I say we are able to do those. That part not do that. That's why we're not expecting. That's certainly yours. That's not that's one of the 7 populations. So these are structures. Whether it does, whether the answer is the city, a setting of that's not, I took that off. So that we got something 7 when we all hands on the plan. But this was inside of the David will call the essence. So I have to think, I need all of the complexity as it's not at the class. That some talking to forms any creative but also another several versions of the so makes sense. Well, we started data science so we can this is big levels small really close because this is to see things that is not easy to create all of them responsible of the work of creating for development in that's so but I did develop the soul but at the beginning this is probably not solved because they're all they solve they're all something so not the place so then so the line of the practical or content is I see I know they are using this and then but it's but it looks as if I don't know to my but I single eyes. There are all the cameras some use all so so whether behind stop and I'm not product doing the labor copy. I have done all those kind of things. I got a start that's why it's absolutely. If you want,
Are we good? Yeah. So I'm sure it's I think that
Yeah. For example, yeah, so for your case, for the country now, for this, and for trying to express them, I got to do something. He's very much on this. He found out they might be there. Who we have that does. That's not the balance is over the whatever they go behind for the gas. I can. Yeah. When I'm still, you have to say that, but yeah.
I think if I can have the leads up here who are going to present or share out from the breakouts. Who's sharing from the breakouts? From your group? Okay. All right. I think we are almost at the tail end of the day. And it was really amazing that even at the tail end, people were having like really vibrant discussions. And I was like, this is a passionate group. So I'll just ask each lead to come up and talk through their breakout. So Chaya, do you want to kick us off?
So there were two questions that we discussed, and we had a very productive and good discussion. So the first one was what minimum evidence should be required for an integrated geospatial data set. And so for that, we all largely concluded that the data set that one is using, we should provide as much description of that as is possible. So it could be about the resolution of the data when we are looking at geospatial data, the scale, the spatial and temporal aggregation that we used, and also sometimes when we use the satellite data, sometimes at a particular time period the satellites will not be functioning. So all of that needs to be documented properly. And in other domains, the data can be changing at a fast pace. So that data evolution also needs to be described. So what has been changed, that all needs to be documented. And then the next question that we addressed was about who is responsible. So since the data is being used not just by the producers but also by people who are modeling the data, using that to run their models, so it's a shared responsibility. So it's largely with the producer but also with the publisher in order to ensure that the quality of the data is good. And we also had a consensus about reviewers should not just focus on model performance but also on the workflow that they used in order to create that integrated data set. So that was what we concluded. Thank you.
All right, we were the AI fair and bidirectional group. And we fired up the data set evaluation agent and took it for a live demo. We evaluated a NASA data set. It was interesting because, the checklist and the skills were developed for biodiversity and ecology, and the agent pointed out that we were evaluating a different data set. But like there's a lot of overlap. So about 80-ish% of the criteria were still within scope. And so it gave us some results, gave us some recommendations. It was interesting seeing like sort of the same sorts of things that appear in terms of gaps for AI readiness for both the sorts of data sets we've been evaluating in ecology and environmental science, and for data sets in adjacent fields. So for example, there was like a gap in provenance that it identified, something that comes up in the sorts of data sets we look at. And then we also started talking about what are ways that we can think about updating the content of the checklists for other domains, and thinking about sort of mechanisms to do that. And then also, like, importantly, we kind of started to think about ways that if we can make these linkages with provenance, we can think about ways to update the metadata. For example, for downstream uses, like say there's a drive data set, a lot of processing that goes into taking a data set and making it useful for, some modeling task. One of the criteria that we're proposing is that should round trip its way back to the metadata for the source data set so that all that work had already been done preparing the data for some AI ready task. So other folks, when they find the data set, the metadata are there to say, all right, this work's already been done. You can go downstream, and potentially use this work that's already been done. So there's we started to think about and see some of these linkages and how they can be used in round tripping. So I'll leave it at that. Thank you.
Hello, everyone. So we had a pretty good discussion on regarding AI-ready knowledge graphs and also the decision support going behind it. So one of the key questions that we discussed was like the minimum requirements for the knowledge graph to be ready, which before an AI system can use that data responsibly. And we initially discussed regarding the difference between like the prompt design and the prompt engineering going behind designing the data. And one of the key things was the prompts involving results for and defined tasks, but not to make the model intrinsically more intelligent. And also with the case study from Hashir, we discussed the knowledge graphs pipeline he had for the illegal trade supply chains and how the different knowledge graphs start hallucinating using AI on top of it, and the different suggested schema first approach that we can use before feeding the data into the AI. And some of the examples raised was, say, a location such as Florida and New York as nodes with transportation relationship and attributes such as methods or volume. And regarding the validation concerns, some of the key things that we noted was the completeness, the correctness, and the hallucination rates. And the possible evaluations approach we discussed were like comparing judgments from bringing different LLMs rather than like judging from a single LLM's point of view while analyzing and going through the data from the knowledge graphs. And we still have like a few questions, and the next steps we can like kind of think about. Some of them were like creating a human labeled evaluation set while going through the evaluation stage and deciding the acceptable thresholds for like accuracy, completeness, and also hallucinations. And also, one of the key points was establishing a risk-based validation policy, which would give us high impact outputs and which would receive a stronger human review than exploratory analysis. Thank you.
Thank you to all the breakout leads. I don't know, Anand, do you want to close this out or Shannon?
Yeah, thank you. Thank you again for the breakout leads, and thank you all for staying so long. I know it's been a long day. We had 3 breakout sessions. It's hard, but thank you for getting through that. We do have one more day tomorrow, and I think that's going to be very interesting. We'll have plenaries from 2 of the other institutes we have not heard from. So we'll do that tomorrow morning. And also, we have a panel session with all the 5 leaders from all 5 institutes, moderated by Cliff. So it would be a wonderful panel, and I hope you will stay through the end of it. So we'll wrap up. I think we'll have lunch, box lunches, I believe, tomorrow, and then we'll wrap up at around 1. So we hope to see you all tomorrow as well. And today evening, don't forget, we have the live reception at Marriott. So even if you are not staying at the Marriott, you're welcome to come, and you can welcome to participate and bring if you have others as well, your friends and others. So that's all I have. Anyone else wants to add, Diana or Shawan, before we wrap up for today? Okay, see you all tomorrow then.
Yeah, that's probably why it's that.